Great. Week 7, day second. It's all about designing ad hoc systems. So, like the funny story behind this is first ever cohort started there. Everything was information retrieval. Again, math heavy. People didn't find interesting. So then I always wanted to cover these systems. So I thought, hey, where do I put them? And I said, okay, let me chop down math part. So that's where I freed up the space on Sunday for ad hoc systems. So I like the systems that basically cannot fit anywhere into their particular weeks. I'll put all of them here. So this way we cover 4 systems. First is around distributed task scheduler. That would lay foundation for message broker and relational DB. And now here, let me start with one. So the first statement is all about how to build systems having very strong SLA, especially when we talk about distributed task scheduler. So the key motive of me picking this system is to help you all understand why it is important to break down problem statement into phases. And whenever you're designing any system that guarantees some SLA, some strict SLA, how do you ensure that you meet them? Right? And like, because at the end it's your code, you need to meet them. But what are some guidelines that you need to ensure that that you need to follow that ensures that you meet that SLA? So how to think about such situations structurally, right? That's one. Then we have a very quick discussion around building message broker on relational DB. Now, why relational DB? Because as you would have seen, that relational databases gives us a lot of guarantees, a lot of features that we want. So what we'll do is build a message broker on top of relational database so that we understand the kind of properties we need from the underlying storage system. Now, for example, if tomorrow you want to build your own message broker, you would definitely not be using relational database. You would be defining your own storage layer. That, hey, how will I store the data? How will I retrieve the data? So you can plug in log structured storage that we saw. You can plug in LSM trees if you want to, right? But the idea remains the same, that these are the properties that you need from the underlying storage system. So when we build it on top of relational database, we realize the kind of features we would need from the system. And then obviously you just remove the relational database. Whatever you are writing as a storage layer for that, just ensure you meet those guarantees. Once you meet those guarantees, you have your working message broker. But talking with respect to relational database makes it very easy to have that fruitful conversation and not just drawing random boxes. Third one is about designing YouTube views counter. There is one very interesting high level pattern that we'll talk about, because this looks like an easy problem. We'll not do approximate counting. Approximate counting next week. But more importantly, I'll throw into I'll put you into a situation where this requires you to think in a very counterintuitive way, and more importantly, that would help we all understand the importance of reusability. Again, a high level pattern that I want all of you to know, because it's very common and it's very counterintuitive. And we'll end our discussion with flash sale. And when we talk about flash sale, you'll realize how a lot of other systems are similar, and designing flash sale is not as difficult as you think it is, right? Okay, this is the agenda for today. We'll start with the first one and a ton of brainstorming that we'll do. So the first statement for today, where we'll spend a lot of time, is around designing a distributed task scheduler. So task scheduler is literally anything where you say, hey, I have this task, please run it at 3 p.m. on every Sunday. Right? So that's a recurring task that you are configuring on this distributed task scheduler. Second example would be, hey, I have this task, please execute it one time on 20th of March, 8 a.m. Right? So you give this system a task to execute. Obviously, the machines on which this would be executing has all the libraries and dependencies that you want. But the job of the system is to ensure that any task that is picked up, or any task which is scheduled, it starts executing within 30 seconds. That's the SLA that we're maintaining. You cannot guarantee completion. Obviously, you cannot guarantee completion of a task. Why? Because, hey, if my task runs for 1 hour, right, you cannot guarantee completion within 30 seconds, right? So what you as a system can guarantee is, if your task is scheduled to be executed at 10:01 a.m., it should start executing, not complete its execution. It should start executing before 10:01:30. So you have 30-second SLA within which no matter how many tasks are there, no matter how many people scheduled how many tasks during that time, you should be able to start executing all of them within first 30 seconds. Right? So the way we break down this, so the SLA that we're maintaining is 30 seconds, and we would only allow people to schedule a task at a minute level granularity, which means someone can say, hey, I want this task to be executed at 10:01 or maybe 10:05, maybe 8 p.m. But it would not say 10:01:32, basically 32 seconds past 10:01. No, we are operating at minute level granularity because that's a fair assumption, right? Why would you want to do it exactly at this second? There is no rule, like there is no need for that. Right? So we operate at minute level granularity. We want to have a 30-second SLA, and the two kinds of tasks that we need to support. The first one is to do it at a certain time, at fixed one-time execution at a fixed time. For example, run this task exactly once, or not, I should not use that term. Run this task once at on 20th of March, 8 a.m. That's it. That's fixed execution, just one-time execution of that. Second is recurring task. That tells you, hey, please run this task every day at 8 a.m. And that is recurring. So the way this statement looks very overwhelming at first. Oh my God, we have to guarantee so many things. But the beauty of this is when you try to think about it structurally, when you try to think one step at a time, this is not really difficult. It's more about we thinking in a way that makes sense. We thinking in a way that helps us break this problem statement down into phases and tackling one at a time. Real world example for distributed task scheduler, AWS CloudWatch events. How amazing that tool is. If you used AWS, you know how amazing this tool is. You schedule literally anything and it executes at that time in most cases. They also maintain a very strong SLA. Second, an open source variant of it is Dcron. And a lot of my understanding of the system comes by going through the Dcron's code base. I went through it. I had to set it up for a couple of orgs. And while I was setting up, I got very curious how it maintains SLA. So the best way for me to do that was to go through the code base. So I started going through that code base and I understood that how it is guaranteeing those SLAs. Obviously, I've not built it in production. This is my understanding from the code base on how they are achieving certain things, how they're achieving execution at fixed time, how they're achieving execution at recurring times. Okay, so we'll start with brainstorming. The key thing is, we'll brainstorm on phases. That if you think about a distributed task scheduler, it implies that someone schedules a task to be executed, giving you all the necessary details for it to execute a task. For example, the exact shell command that you need to run. Simple. It gives you that your executor, when it picks up the task, it needs to execute the task. That's all you have to do. But the interesting part is you have to ensure no matter how many tasks are scheduled to be executed, you start executing all of them within first 30 or rather within first 30 seconds of the scheduled execution time. So we'll brainstorm on phases, and these are also hints: store, pick, and execute. And what we'll worry about in this phase is just to execute tasks at fixed time, one-time execution of task. We'll not think about recurring at all. We'll build a very good system around one-time execution, and then we would see how easy it is to extend it to become a recurring system. Right? Okay. So let's kick off our brainstorming. Raise your hands. I'll pull you in. We'll start with store, where how we are storing the task, and we'll pick relational database for that because no need of overcomplication. Right? We'll start with relational database, kind of guarantees, and then you may switch the underlying database to any database that gives you those guarantees. As simple as that, right? But relational database helps us think in a very structured way. Okay, let's start with storage. What would be the schema that you would have for a table that stores tasks that are scheduled to be executed by a particular user? Raise your hands, I'll pull you in. Yeah, Anubhav?
Here, but so given our requirements, I think like since we are only targeting tasks that are to be executed once and not recurring tasks, I would like to schedule what I would like to store in this table is like firstly, let's say a unique identifier for a task for
That's
the
UUID.
yeah, and the timestamp at which we want this task to be executed.
Okay. Schedule that. Okay.
And if we have multi-tenancy or like if we have that sort of a user level requirement.
Nah, that's vitamins, not painkiller, right? That you can add as many things as you want. Okay. But more focus. Only these two things?
No.
Ah.
We also need to store information about what is to be executed, like
The
the
command.
command, let's say. Yeah.
Hmm.
So right now we know that at this time we need to execute this. And I'm thinking what else is here. ID, command, schedule that. We don't need to worry about if it's recurring or one time. I can't think of anything else that we would need right now.
Okay. Fine. Hemant?
Yeah. We may need to think few more things. Maybe schedule at will have a if we are considering timestamp and time zone and all those. If it is in one place, that's okay. But
Unix epoch, direct store Unix epoch. No tension there. UTC times of Unix epoch will store.
Yeah. So job details we are already considering. What I'm considering, this thing is like task or job that has to be executed. So that detail is required.
This is that command, right? That in which that needs to be executed.
Okay. So command had all the details that
all the detail that you want. You store it in JSON, you type a shell command, whatever, all the details that you need to execute a task is right there.
Okay. We may need to see if not from user who can execute and all those things. Do we need to think about
authentication
that?
authorization is different. No, let's focus on just task execution. Right?
We may need to think about something around its success or failure. If we are we considering this thing only at a one time?
No. So we would not have retries, but we would still need to show user the status, right? That it failed or it passed.
Okay. Maybe we can have few things around enabled, disabled kind of this is can be done, not be done.
No, everything has to be done. Everything has to be executed. You just need to store if it is successfully completed or not. Right? Okay. Because you need to show to the user that, hey, this is successfully completed, or rather this failed and this is the error log. Right?
Okay. I'm thinking from one more angle of do we want to have a kind of hierarchy that something else will be done?
No DAG. No DAG. Simple execution. Yeah, simple execution.
Okay. Then the ID command schedule that and okay. It looks bare minimum. Good enough.
But how are you showing status if the task is successfully completed or not?
That I said now that you have to show error or success or whatever.
How? Where? You need to store it in database, right?
Yeah, okay. Yeah, that's why I said success or failure, whatever.
But what's the name of that column? Success or failure?
We can say completed or not something. Completion, status. Yeah.
Okay, fine. So the potential value of status would be?
Potential value is just will be completed, in processing, not started, or failed. Failed. Not started, in progress.
Like scheduled. Not started as in it's scheduled.
At least this. Right? Okay. We are not considering retry, so nothing.
Okay, fine. Okay, I'll pull in Ratnesh. Hey Ratnesh, one quick question on this. Do you think we need status column?
Yes, I think.
Why?
Because let's say one service gets failed, then in case of recurrence, how we identify, or the job scheduler identify that I'll have to reschedule this job for
No,
the
I said we don't worry about retries. We don't care about retries at the moment. It failed, it failed. But do we really need
in that case,
status as a column?
I think in that case it is not needed. This is just for the informational purpose. We can keep.
No, but we still have to show that information that it failed or not. You may not be consuming it, but you still want to show your user that the task failed.
Then definitely we need. Yeah, then definitely we need this column.
Okay, so you say that we need status column. Now, what is the what if what if the query that I write to update the status failed? For example, my task was in progress, the status was in progress, and my task failed. The machine crashed. The status column would continue to remain in progress.
Right.
So then your users thinks that the task is in progress, but the task actually failed. So now what?
Yeah, in that case, it should be an inconsistent state.
Right. So like when you have a column like this, because this is what your user is relying on. So you need to be very thoughtful on how about ensuring consistency across what your task is, what your task actual status is, and you need to ensure that it gets reflected in this column. Correct?
Yeah.
Okay, fine. But yeah, I just wanted to probe that discussion that hey, that it is like when you store something that is quote unquote derivable, try thinking of not having it. But at least for now, it's a good start. We have status column that we can use it to render on the UI that these are the tasks that got executed and whatnot. Fine. Okay, fine.
Yeah.
Let's go. Yeah. Just a minute. Let me just complete this. I'll pull you in. Just a minute. Right. Okay. So here, this is very similar to how we thought of while we thought of not storing the S3 file path in the database because we could derive it. So I just want to plant these seeds in your head. If you all can think on those lines, it would come in handy. It's not that we would be brainstorming it right now, but once we start thinking of implementation, we would be reconsidering this decision. Right? I just wanted to plant that seed. Go on, Ratnesh.
Yeah, apart from this, I think we also need to have a column for the frequency.
No, we are not. We are just doing one-time execution. You don't need frequency. Okay. So we are not doing recurring at the moment. So the thing is, if you look carefully, recurring task is actually just one-time task executed multiple times. Correct?
Okay.
So which means if you just do if you ensure your SLA for one-time task, it would become easier for you to extend your system to support a recurring task. Correct? So that is why solving one problem really well and then building a solution on top of it to support recurring is easy.
Okay, got it.
And thus this goes for everyone, that whenever you see a problem statement that has typically such phases and so many things in it, one thing that you need to think about, that instead of getting overwhelmed, instead of tackling all the requirements in one shot, take one thing, solve it really well, and then see how you can extend that solution to support something else. Because if you look carefully, recurring task is actually one-time task scheduled multiple times. So it seems like a solution that you can build on top of one-time execution, because in any case, one-time task scheduled, you have to maintain that SLA, be it recurring, be it one-time, you have to maintain SLA that once it is scheduled, you are executing that thing within 30 seconds. So which means that you would anyway need to solve that one-time execution problem really well for you to be able to build recurring tasks. So that's how I would have approached it, that instead of getting overwhelmed by, oh my God, these many requirements, I'll store everything. Because a lot of people think that once you start designing DB schema, you cannot come back and change it. Right? So and for some reason, people think of it as exclusive phases of design. That I'll first design the schema, then I'll start thinking of execution. And then a lot of people think that I have to design entire schema in one shot. Why? That's not how we work, right? Once we start thinking of implementation and we uncover new things, we can come ahead and change that schema design anytime we want, right? So always keep these things in mind. Don't be hard on yourself. Take things slow. It's okay. Do it step by step.
Yeah.
Okay. Thanks, Ratnesh. Okay. Now, for us to go now, okay, we all agree this is the bare minimum to start, right? Bare minimum to start with. Now let's start thinking of implementation. So storage, bare minimum to start with, we will obviously need to add a few more columns. You see, I left a huge space over here, a huge void over here. So we'll have to add more columns, but for us to build that intuition, we'll go to the next stage where we first done store. Now we want to pick the task for execution, right? Okay. Jatinder, how would we pick task for execution and how would we execute? What would be the flow for that?
I think whenever we push something into the database, we probably want to schedule a cron also for that.
You are the cron.
Yeah.
Right? Distributed task scheduler is the cron. So, okay.
Yeah, so we need some way to understand that like at every minute, like which task is supposed to go now. We definitely can't like scan through the whole DB. I mean, we can do that, but that's probably not what we want to do.
So this is your database. Up until now, you have stored this task, right?
Yeah.
Now, what you need to do is you need to pick this task for execution. Now, who will pick that task? Maybe a service that is constantly firing queries on the database.
Yeah.
So let me add a service called what should you call this service?
Executor.
Okay, executor. So what would be the job of the executor?
It's supposed to like pick the tasks from the database that should be executed in this current minute or something.
Okay, pick. And would this machine also be responsible for running the command?
It should probably like delegate that to workers.
So then what is is executor not a worker?
I mean, I think we will probably have like one service that picks the tasks and like schedules it. Like maybe like we could probably call it.
Why can't you merge it? What if this machine picks up the task and executes it?
Yeah, we can do that. We can do that. Yeah, we can execute.
So then why did you go with that other approach where it was not doing that? One machine to pick that up, other machine to execute it.
I mean, it feels like it's better to like separate these concerns. Maybe like something that can schedule things and maybe.
No, that's a good point. It's your intuition is kicking in, right? That is a good part. But you cannot just write in a design doc that I felt like this. It has to be backed by some reason, right?
Of course.
Right?
I mean, like scheduling.
What would be that reason?
Like having like less logic in an executor. Like an executor could simply be a very dumb machine, like a very dumb machine which you just give a task and it executes. Right, and we can spin up executors as we want while there's a scheduler which is supposed to like hand those tasks out.
Why? Why can you not do it in one machine? Because when you said, hey, I felt like, because intuition is good and I'm not even denying it, over time you would build those intuition.
I mean, one thing can be like if we have like more workers spinning up over time, they probably need to register with this scheduling service, right? So we can spin up more workers on demand as we go on, and they can
you can anyways spin up those more machines and what at this stage, this one machine doing both the things. What is the responsibility of this machine? When it comes up, all it does is start querying the database, picks up task for execution, and it executes it. They don't need to register somewhere, right? They're just reading from the database, picking up a task and executing it. Right. It's not major reason. Like there should be a strong reason for us to not split. For us to split this into two set of machines. One that is picking up, another one which is executing.
Right. Yeah, maybe I'm not able to think about it right now.
No, but having that intuition is good, but your intuition needs to be backed by something rational. So keep those things in mind always. Right?
Definitely.
But it's good. Like you are thinking, you are directly been able to converge onto a more optimal thing. But obviously, when we write documents about our design, we need to be a little more explicit into why are we not going a certain route. But good enough. Rahul, why should we split these into two? Or what would go wrong if I have this in one, picking and executing?
So it's kind of like when we are creating just one machine, it's kind of like making a general machine which is doing everything basically. And like if you have seen the case of Jenkins or TeamCity, basically we have specified machines which execute specific type of commands. For example, Python has Python, Golang, all of them has different machines basically for executing them. So in the task, we do not know which type of API, like which type of commands they are executing. So for that, we will basically have like executor for that. Instead of making general machines, we should make specific machines which execute specific type of commands. Let's just say like there is a command for Golang, or there is a command for Python, or there is a command for building Docker images. Like there can be anything, and like making executor that much general to execute all of them will make the system bloated, basically executor bloated.
Okay, that's a brilliant point. For example, if there is a task that requires GPU, why would that machine which is GPU specific should pick up any random task to be executed? Right? So which means that in the task table, you may need to store, like you may need to derive that information from command somehow, or maybe have another column that tells what type of machine you would want to run it. But still, what if I have set of executors? Some are GPU executors, some are mem executors which have high RAM, some are, let's say, high disk executors, some are Java executors, and they all pick from the DB, assuming that they know which task belongs to what. Let's say I add a type to this also, right? Which tells me what type of machine should this task, or what type of runtime should this task be executing on. That would solve the problem.
Actually, it would make the executor kind of like a single point of failure. If like, let's just say like basically if executor pulls something and it basically runs the task and it crashes in between, the task is gone.
Yeah, that's one that we are okay with that at the moment, right? I'm thinking about why should you have picking and executing in like what could go wrong if you have both of this in the same machine? Like this machine picking up the task and also executing it at the same time.
I think like the most of the reason that I think is like the machine will be pretty bloated. That's like
okay, you are going on the bloated side. Okay, that's
yeah.
But we did make a note of it. Okay, let me give a hint so that we converge onto this. So before we do that, let's start writing the query, because that would make it very clear on what could be the potential challenge. I'll just pick folks who just tried. Okay, Anubhav, I'll just do you in 1 minute. You just keep your hand raised. Nitin, go on. Let's write a query for this, right? So that it like everyone is on the same page. What would be the query that this machine would fire on this database to pick a task for execution? This is the schema.
I mean, select star from this table where the status hasn't started. I mean, is scheduled.
Select star from tasks where status is equal to schedule. That's it. What if I scheduled a task 1 year from now? This query would match that.
I mean, we need to add the, I mean, whichever is the recent schedule.
How? You may do order by. But still, let's say if there are no tasks scheduled for next 1 year, this query would still match the tasks that are scheduled after 1 year. Why? Because you're not supposed to start a task so much in advance, right?
Yeah, I mean, in the next 30 seconds or some kind of time constraint, we need to
correct.
act where.
So what would that be? But who's not on mute? Is it coming from you, Nitin? The
Yeah,
background?
I just coughed. Sorry.
Oh, it's okay. Okay, that's fine. So select
Okay.
start from task where?
Where scheduled underscore add is less than time dot now minus 30 seconds.
Minus?
Some seconds
Minus or plus?
plus, sorry. Plus.
Okay. That's it. Would this be your query? Okay, there is some background noise on Nitin. So I'll pull in Anubhav. Anubhav, sorry.
Sorry,
Acha, you are back, Nitin. Okay, sorry. Go on, Nitin. Select start from task or schedule that is less than now plus 30 seconds. This would pick the tasks that are about to run in next 30 seconds. Right? Okay, so pick the task. Is this the query that you will write? Or should there be something more to that?
Obviously the status clause also, I mean, where the status
You have
hasn't-
scheduled that. If you have scheduled that, obviously it would not be picked. Okay, fine. Anubhav?
So do we want to pick only one task, I think, because this query will select a lot of tasks. So
correct. So you need to make things predictable. You need to know exactly how many tasks are you picking. So what would you do? Because this machine is doing this part, correct? What would you do? This machine is picking and executing. If you pick up 10 tasks and just execute them one by one, that would slow things down. And it might be possible that your machine crashes. You are not even started executing the other 9 tasks, right? So it's better to pick one task at a time, given that we have those machines same, like one machine doing both the thing. So you put limit 1. Okay. Anything else you would add to this query?
But with limit 1, it is also possible that at times we don't get any, but like at times we don't.
So in that case, it would not have any. No, it would just keep on. It would just keep on firing this query again and again.
Okay, so yeah, that prompts me for something that is non-query related, like something that we can improve in our executor, but I'll hold on to that.
No. What else can we add to this query? Hemant?
I can't think. Yeah, Hemant.
Yeah, I'll pull it here. Yeah, thanks, Adhoc. Hemant?
So I'm thinking from the direction of this is the same database will be used where we have to add our jobs, and from there we have to retrieve our jobs. And there will be a lot of let's say connections on database. Some are writing, some are reading. And if we start thinking from only perspective of this query, and if some task comes once I read it, maybe within few milliseconds after that, will that be missed? How we can make sure
it would not be missed, right? It will not be missed. Look at this query, it will not be missed.
Scheduled at is less than now plus
30 seconds. So even if a task comes very late stage, you would still not be missing it.
So we are saying that the task when added in the this table will have at least a one minute before, so that it doesn't miss. Because
exactly. At least 30 seconds.
At least 30 seconds.
But even if it is even late than that, your system will still pick that up. This query still allows you to match that. But in that case, you would just be breaching your SLA. But you would still match it because your schedule that is less than now plus 30 seconds. So you would still you just breach the SLA, but you'd still be picking the task for execution.
Okay. So beyond that is the concurrency which is running in my mind.
Brilliant. Brilliant.
How we will make sure that only I mean the task which is retrieved is retrieved, and now the next thread which is coming or on a separate connection on database is not retrieving that one.
Exactly.
I'm not able to figure it out how we can do it here.
Exactly. Right? Because that's why I just redrew this to make it clear that we not have one machine. We have 3 machines. Now this machine, because if each of this machine fires this exact same query, And if let's say I have 3 tasks, 1, 2, 3, executing like these 3, all of these 3 matches. Now, what would happen if I fire this query, all these 3, and if this query is fired by 3 machines at the exact same time, the database would pick this exact same row and return to all of them. So the same task is picked for execution by multiple machines. Classic concurrency problem, because now you do not have just one machine picking the task, you have multiple machines which are constantly picking the task. So you need to handle concurrency. We did that already.
Yeah.
How?
We need to lock that row and read and say that I read it and updated the status to like pick date or in progress in a one
But
single.
when you lock the row, would other tasks be able to pick that?
No, it will not. But that's why we have to take the write lock so that it does not come in the other transactions purview.
Perfect. So what's the query now? Select start from task for schedule that is less than now plus 30 seconds.
And update for update we have to write for update whatever that this row comes by ID or something, we have to set status picked.
No, that is update part. Okay, so that would go as an update query. That would store something. So we'll basically come to that because this query is still not done.
Yeah.
This query is still not done. Okay. Now, what would happen when this query is fired by multiple people, or rather with multiple machines at the exact same time? Let me quickly draw the schema. Let's say the current time is 10:00. This task needs to be scheduled at 10:00, 10:00.
Yeah.
All 3 of these tasks match this thing, right? What would it look like? And we will also add order by over here so that we pick in order. Order by scheduled at limit 1 k chunk of that. Oh, I can have limit 1. That's fine. What would happen when this query is fired multiple times by the is fired in parallel by multiple machines at the same time?
The challenge is with the time. So when you say order by and each timestamp is same for schedule at, any one of them will be picked.
Anyone, the first one will be picked, not anyone. It's in order. Your database will not just randomly pick one of them.
No, I'm saying so in the schedule that if all of these are like same, okay. So let's say four rows or these 3 rows came before the limit by query execution plan. Okay, then you will take one of them.
First one of them, because in any case on the disk multi-structure, some row will be at first, some row will be at second, some row, although they are stored at the same time, but they would all be going for that same row contention. Limit 1.
Yes. So that's why I'm saying how to differentiate which one will be taken by a one connection, which will be taken by another.
That's the job of a transaction to do it, right? You need to write this query, and this is where your exclusive lock comes in. When one transaction came in, it took exclusive lock on one row.
Okay, got it. So because of
that solves the problem.
Got it. So because of that exclusivity, I will get one row.
And now, that row cannot be read by other transaction. But now when other transaction came in, then
when other transaction, it does not see that row.
Why?
Sees, because we have locked it for write and read.
No, your other transaction waits. When you take exclusive lock, it waits for the first transaction to complete.
Okay, what I'm trying to say is one transaction comes, it runs the query, okay, and it gets that, and then another transaction takes and it takes the T2 row.
How? Why? Until your first transaction commits, second transaction would not pick up.
Yes, so that's why we are solving the concurrency that only one at a time we will pick only one row. Other transaction has to wait. One first one will be picked up, and then second will be then third.
Sure. Okay. So this solves a problem, but it introduces another problem. Let me pull in. Wait. I'll put in Pankaj. Pankaj, what's the problem with this query? Like one transaction coming in, picking up one row at a time in this way with this query.
So basically it will be like, let's say if at 8:1 I have 3 tasks scheduled and 8 o'clock, if 3 machines are firing this query, if till the time one gets it and updates it, the other two have to wait.
Perfect. Correct. So what's the solution for that?
We have to use something like skip log, which we discussed,
Perfect.
so that the other machines like basically move on to the next task and take them.
Exactly. Because we need we need high throughput, and that's a perfect way to write this query for update skip log. Because when one task has taken, or rather one machine or one transaction has taken an exclusive lock on a particular task, other task does not have to wait for it. Other task can just skip the locked rows and move to subsequent rows and start executing it. There is no point in waiting, like for other transaction to wait for the first transaction to complete and then see, oh, now this is gone, now I'll pick the next. There is no point in waiting. What we discussed in second week with online offline indicator, the airline check-in system, that same thing applies over here. We need very high read throughput. There is no point of some transaction waiting for other transaction to complete before it can move to the next one, because you have multiple machines. You need to keep on, you want to keep on reading the rows, because you don't mind. If one transaction has locked a row exclusively, your other transactions can move forward. So long as it matches the query, they can just move forward and start reading and executing the task, right? So this becomes a complete query that we would need to run when we fire from these machines. Rather, these machines would be firing this query. Okay. Now my next question is, this query is perfect. Now my next question is, now do you see a problem with this machine doing both picking and executing? Look at this query and see what this machine is doing. It is also picking and executing. Do we see a problem? I'll pull in. Yeah, Pankaj, you can continue and then I'll go to Rahul. Yeah, Pankaj. Do you see a problem with this machine doing two things?
So I have a feeling that somehow like 2 transactions might get picked up by a single machine. So we need like
That's okay.
Yeah,
it
so
would anyway be multi-threaded, right? So even if two transactions are running on the same machine simultaneously, that's not a problem, because it's responsibility of a database to handle this, and you have written those corresponding constructs that would ensure that your data does not go in an inconsistent state.
Yeah, so now I think like particular machine can execute because it will get a unique transaction of which it is trying to execute. So if it wants, it can execute that transaction and then put that status in progress or whatever we are.
That is solved problem now, right? Now, once you selected, then you would also write an update part over here. Update tasks set status equal to something where ID is equal to something. This would be happening in a transaction, right? So that is solved a solved problem. That is a solved problem. But now again comes the same question. This machine doing two things, picking and executing. What can go wrong?
So one more thing is yeah, since it has to execute like these queries in very little amount of time, I mean 30 seconds, the task which we are giving them should be like basically executable in like very less time. If they take too much time.
Why? I can schedule a task that runs for 1 hour.
Yeah, but it is consuming the resources of the server, right? So
what's the problem? Your task anyway needs to run.
But like the main the main thing which this server has or the service has is to basically pick that task up and schedule it.
No, the task is already scheduled. You just need to run it, right? Because you are just going by the narrow margin of 30 seconds. You are just constantly running it. You need to pick and immediately start executing. Okay, let me give solution to this. Like, why are we doing certain way? And then because we still have a lot of things to cover, still very granular discussion or like very granular decisions that we need to make. Okay, one reason why this needs to be separate out into picking and executing is because now if each machine is not only just picking but also executing, the problem with this is if there are 1 million tasks scheduled at this exact same time to be executed, Imagine the number of machines you would require. Those many machines would be firing query onto this database to get things done. So many number of connections you would require. Your database, this relational database, even if it is not relational, it still holds true. The number of concurrent connections this database would need to maintain would be to each and every machine that is executing. Now, hear me out. If assume that I have 1 million tasks, each machine picks up one task and starts executing. If there are million tasks scheduled at this very moment, there would be a million machines because each machine is picking up one task. And obviously, you can optimize. I'm giving a hypothetical example to help you all understand the problem. And I would need a million machines to run this task, right? So that I can run 1 million tasks and I can complete 1 million tasks to be executed at this exact same time. When I have that kind of thing, each machine would be querying this database to do it. So I need to handle 1 million concurrent connections on this database. That is not possible because database has a limit. So when you have a large number of tasks to be picked up, you cannot have, if there are n tasks to be picked up, you cannot have n machines to pick those things up because the number of connections is limited on this database. So which means that it is ideal for your database that you read a task in batch. Instead of reading one task at a time, you read, let's say, 10 tasks at a time, and then delegate it for execution. This way, what you do is you minimize the load on the database. The job of this machine only remains that, hey, I'll just keep on picking the task and delegating it for execution. Now, these are the tasks that needs to be executed right away. So you obviously put them in a queue. The job of picker, if I may call it, the job of picker would be to simply pick the task, 10 tasks at a time. This query is continuously being fired. The job of picker is to keep on firing this query literally in infinite loop. And it would keep picking the task and keep putting them in this queue for other machines to pick up and execute. So now let's say on the production side or on the executor side, I have different sets of machines, one optimized for memory, one optimized for Java, one optimized for Golang and whatnot. And the picker can then put the message in the corresponding queue. If you have multiple queues, you can use Kafka and whatnot, have multiple topics, different ways to implement it. But the idea is that you would have different types of executors that are specialized machines whose job is to execute that particular task really well. They don't care because now, even if there are a million tasks, the number of pickers are limited, creating number of limited concurrent connections to this database, keeping your database sane enough. Their job is to pick the task continuously and put them over here. This would be buffered over here. And now executors, now you can have hundreds and thousands of executors over here, whose job is to pick the task from this machine, from this queue, and keep on executing them one after another. So this is why you need to have these machines only pick the tasks that are eligible for execution right away, put them in a queue, let workers pick that up and start executing. This reduces the load in this DB because now you are not reading just one row at a time, but 10 or 50 or 100 rows at a time. This way, when you have million tasks, you would not require million machines over here to read them and execute them. This is now a decoupled system. That one is picking up, another one is executing, right? Okay, now, but this introduces few interesting problems. First of all, one key thing, like, let's go into the part that how are we ensuring, or no, not ensuring. How do we know that we have not breached the SLA? The SLA is the time at which the task was scheduled to be executed. Let's say it's 10:01. That's when the task was scheduled to be executed. How do we know that by the time that the task starts executing, it is within 30 seconds of time? How do you know that? Rahul, what kind of things would you build to ensure that you are maintaining that SLA?
Actually, I didn't raise I don't have any idea about this, but like there is a system point, like there is a derived point for like decoupling these things. Can I say that?
No,
That's
no.
okay.
First, let's jump to that. We can have it afterwards. Huh?
Yeah.
But think on those lines now. How would you build observability on this system so that you know that you are not breaching an SLA? That's important.
I need to think about this.
Okay, fine. Nitin?
So, so we have to make sure that we have enough workers to execute the tasks which are in queue, and we need some kind of orchestrator which will spin up, which will auto scale
Correct.
or to scale down the workers. Okay, so there should be a orchestrator which will observe the queue length and
Perfect.
how much. So depending on the time and like certain other factors like the queue length and how many workers are currently working on it, and based on that, it will auto scale up or scale down.
Perfect. So that's one. But for you to know that, hey, you need to scale up, you need to know when to do it. It's easy to say, but now think about implementation. Right? That how would you know that you have, first of all, you need to know that you are maintaining that SLA. How do you know that you are maintaining that SLA?
Okay.
So here what you did is you are jumping onto solution that, hey, this is how I maintain SLA by auto scaling things up. Right? But my question is one step back. And I say that how do you know that you are maintaining an SLA?
We do need to maintain. I mean, every so what workers is working on what job in that direction. That their metrics all we have to maintain and
Where would you
currently
maintain that? Where?
in the DB only.
This table?
We can have it in this table or we can have it in separate table.
Why separate table? Give me one reason to have a separate table. You know how
sorry.
simple systems I feel. There has to be a reason for you to pick a second table. Huh?
Yeah, I was thinking in the terms of that recurring cron.
Don't jump into that. That's what I'm saying. Don't jump into that. Solve this problem one really well and then extended solution.
Yeah, I mean, we can have another column where a worker ID or something which we are maintaining, and
you don't need. Why do you need to know which worker is executing? You don't care which worker is executing. Correct? You just need to know when it started executing. Correct?
Yeah, when it started executing and 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 when it has ended.
Correct. Okay. So first let's talk about started at. The difference between these two should be always less than 30 seconds.
Yes.
Correct?
Yes.
This is how you would know that you are maintaining your SLA. Correct? That in case this breaches, you know that, hey, this is the task that breached the SLA. So then you figure out why that is happening. Right? So the step one in ensuring that you are meeting an SLA is to know that are you meeting an SLA? Then you would know. Right? So first we are measuring things. So started at is one. Okay. Now this would help us, scale up kind of. And then you also talk about, okay, this is one that you added. When it started at, you also talk about when it ended at. So completed at. Will you store completed at? And will you also store failed at?
Yeah.
Why two separate columns? Why not just one column?
No. If it so let's say completed ad would only suffice because if let's say if our worker abruptly crashes down, then this column would be empty, and then we have like the orchestrator will maintain like what happened to this job and why, like, since this much time has been passed, like 30 minutes has been passed, still there's no update on this job.
How would it know that this task was supposed to complete in 30 minutes?
No, 30 minutes is the maximum.
No, but how? How did you come up with that number? What if my task is just about updating some, what if my task is just about downloading a web page and uploading it somewhere? That task would not take 30 minutes. Why should I wait for 30 minutes for that?
Correct. Then, so then the another metrics like which worker was executing it and
You are
what's
so
the status
stuck
of
on
that
which
worker.
worker is executing it. Why are you stuck on which work? You don't care which worker is executing it, right? What you
Because
care is what type of task it is. Correct?
Because how would we know that what's the status of that job? Like whether it's currently executing or whether it crashed or
You just
the worker
spoke
crashed.
about it. If it is long enough that your completed at is not set, then it means that the job crashed. There is no way for you to find it.
Then yeah, then after how long time we should conclude that this is still not running?
That's what I'm asking you.
So that's where I mean we could get to know from the worker
Worker doesn't
so
know
like,
stuff because worker would be also storing it in some database, right? So if the task failed, worker would not have been updated their database. Correct? It might be
correct.
storing it somewhere, right? Even the worker did not get chance to update it. Okay, let me go. Let me talk about it. This is where we need to store these two into separate columns. Completed at and failed at. Completed at is when your task was successful. You would know how much time a particular task takes. You can use this multiplied by 1.5 and set it as maximum. So when your orchestrator is checking if this job would have completed or not, historical data would tell it that for how long would you need to wait before you can conclude that the task failed. Which is why having success, having stored your completed at, your successful completed at in this column is important. And why I'm storing failed at in separate column? Because typically when a task fails, it fails fast. For example, when there was an abrupt ending, don't think of just your task failing equal to your machine crashing. It could also be because of an exception that came, any runtime exception that came that crashed the process or crashed the corresponding thread. Now, what would happen in that case is you typically see failure times to be very short as compared to successful times. So if a task is successful, it might take 1 hour to complete, but if it fails, it might fail in 2 seconds. Now, you don't want these metrics to get skewed up because of that. If there are a lot of failures, then the average completion time would be very small, right? You don't want that to happen. You want to have a very streamlined way where you exactly know, for how long for how long should you wait that you can now claim that my task failed. This is where for every type of task, you would know that what is the average time of completion. You multiply it by some factor, let's say 1.5, and you wait for that time. That if until that time, no one updated the completed at, which means that the task would have failed at. If it's runtime exception that your process is handling and killing itself, you may choose to set failed at in that case. But if it is an abrupt thing that you don't know, because there are some exceptions which you yourself are generating. For example, let's say a task was requiring a particular parameter. You did not pass it. You explicitly mark the task as complete and you kill yourself. But if it was abrupt failure because of a runtime exception, then you would not get chance to do it. So in either case, you would have a separate column that tells you on an average how much time it requires for you to complete a task, an average of those columns. This is what your orchestrator can use to deduce if this task is completing or running and failed and whatnot. Right? Okay. So now we have started at, completed at, failed at. Now, if you look carefully, we sorted this thing out. But now, how do you know how much time it is waiting in this queue? Because how long, like you scaling it on basis of queue length, but you need to know how many machines you need over here. Here, if you look carefully, there are multiple stages through which your code is going. First is where you are picking things up. So now you need to provision the number of pickers that you have depending on the number of tasks that are scheduled to be executed. So what your orchestrator would do? Orchestrator would actually look at this database, and figure out, hey, within next 5 minutes, for example, how many tasks are there? How many tasks are scheduled? Because you are doing a farther forecast, 5 minutes time, you would have time to spin up infrastructure for this, right? Now, when a picker runs, one picker runs, you know exactly how much time one query would take, because this limit 10, because it is limiting the number of tasks you're reading in one shot, you would exactly know how many machines you need. Because if it takes you, let's say, 5 milliseconds to pick the task and put it into this SQS queue, let's say I pick SQS queue, you can pick Kafka as well, not a difference at all. But if you need to know during this one execution of picker, where it is reading 10 tasks, updating the status of the 10 tasks will come to up the status column in some time. And picking and updating it and putting it into the queue, if let's say this takes 5 milliseconds, and you do this by measuring, not guessing, by measuring it. When you do this, you would exactly know how much time it takes for you to do it for 10 tasks. So you would know how much time it would take for you to do it for n number of tasks that are there. Right? And your picker is continuously running. Now, if the job of this picker is to not just put 10 tasks and sit idle. These machines are literally continuously firing these transactional queries on this database to read, put, and repeat. So it would read these entries from the table, put them into SQS queue or Kafka, whichever you are using, and update the entries in this database that, hey, I update these entries over here, that these tasks are now picked. Right? Now, what you need to do is the first thing that you need to measure is how long it takes for you to pick that task. Because you need to know, you cannot just rely, no, it will be picked. But why? How are you so sure it will be picked? You need to measure that, hey, what's the time? So whenever you're building a system which requires very strong SLA, you need to know how much time each phase is taking. So the first phase is the task entry is there. After that, you're picking. So how much time is required by you to pick a particular task, right? So when a particular task breaks the SLA, you would need to analyze how much time, like how long it take your picker to pick this task and put it into the queue, how much was the wait time in the queue, and how much time it took for an executor to pick out from this queue. These are the three phases that you would need to have. So which is where, instead of just having this started at directly, we would have a column called pick that. This would tell you when this task was picked by the picker and put into the queue. The time at which it is put into the queue, this is what is being registered over here. This way you know that how long it takes for you to read that task and put it into this SQS queue. So now, if this is where, once you know the average time to pick for a particular task or average time to pick, you can scale up and scale down machines according to that. Because you need to know how many pickers you need. Right? This would tell you the time your task scheduler is spending in picking the task and putting it into SQS queue. The second thing that you need to know is how much time it is taking for your, like once a task is in SQS queue, how much time it is taking inside the queue. How would you know that? This way, you know the difference between picked at and started at. So when an executor picks the task from SQS, the first thing it does, it updates the database. It updates the database and, hey, now I've started executing this task. The difference between picked at and started at is the time at which your task is spending waiting in the queue for execution. If this time is too large, you would spin up more machines, right? Because now you know that which is the bottleneck, which part is bottleneck, and which one what you should be optimizing. So you need to store the timestamps exactly like that so that you know which phase is most time consuming phase over here. So scheduled at, picked at, started at, completed at. Completed at would help us know on an average how much time a particular task takes, and depending on the types of tasks that are scheduled, you can then provision the number of machines over here. Because let's say at a particular time there are a lot of heavy tasks that are coming in that are on an average taking 1 hour to complete. You would require much larger instance. So scaling of these executors is not just dependent on the queue length. Because if you just think, hey, queue length, it might be my queue length only has 10 tasks. I'll just need one executor. But what if each of the 10 tasks takes 1 hour to execute? right? Scaling is not as easy as just monitoring the queue length. Scaling is with respect to going through the data, seeing what type of tasks are scheduled to be executed, depending on which you will find how much time each of these tasks might take depending on historical data, and then you add those many executors in place. This is what actually dcron does. If you go through the code base, you would see this is what they are doing. That scaling, it's not just a property, because that would, you would just measure the queue length and scale it on that. Is easy when almost all the task takes almost equal amount of time. But as soon as you have high variance in the task, some task takes 1000 seconds, some task takes 1 second. Then if there are a lot of 1000 second tasks that are scheduled, problem starts to kick in. The number of executors would be less, and then you would not be able to meet the SLA. So when you want to proactively meet the SLA, you have to measure literally everything and scale accordingly, scale into considering all the features rather than just some vanity metrics that is easy to get. So getting queue length is a vanity metric. You can very easily get it. But is that the best one? Not really. Because your distributed task scheduler is not supposed to execute at just one type of task. Right? So just one change over here, that if you look carefully, now we don't need status column at all. We can just derive status column. And in either case, you may choose to keep status column also. You can choose to remove it also. Either way, it's fine. But the idea is that if something is derivable, why to have a status column for that? So, but I'll still keep it because why not? But it's just be sure that it might go in an inconsistent state. So, but you have anyway got it covered, that you know average time of execution of a particular type of task. You can then update a status column and set failed at some time and whatnot. Right? So few things that would change in this query is your picker, when it picks up, it fires select star from task where schedule that is less than now plus 30 seconds for update skip log order by, where schedule that is this, and you need to pick up tasks that are not picked up. So, and pick that is null. Right? So tasks that are not picked up yet, I want to pick up those tasks for execution. Right? Order by schedule that limit 10. And then they would update status equal to this and pick that is equal to this, where ID is equal to this. Right? You keep on doing this every single time. So now your job of picker is to continuously pick the task from this database, put it into SQS. The job of this workers is to just pick from SQS and start executing. These are specialized machines. Now you can add multiple queues over here, one for each type of task. Picker putting them into particular queues. Vitamins, add more vitamins to the system, more complex you would become. But this is the heart and soul of building a system which maintains a very strict SLA. First, measure what matters, and then take actions according to that. Right? So build those observability in depth before you just add boxes. Think of rather before you jump into maintaining that SLA, first understand what you need to measure. Right? Okay, so let me formally cover this and then I'll take questions on this part because there's still a couple of things that I need to touch upon. Right? Okay, I'll take questions in some time. Okay, so in the storage, we discussed ID. Task is basically the command, scheduled at, picked at, started at, ended at. This is what we would have. Now, what we want is we would want to be someone has scheduled a task using APIs, task APIs. Someone has scheduled this task to be executed over here, and it gets put into this database at this moment. So from this database, we need task pullers who are pulling the task from it. And we do not have just one task to pull, or rather one puller to pull. We would have multiple machines because there might be thousands and thousands of tasks that are scheduled to be executed in this moment. So given that, we would have multiple pullers that are over here. So all of them would be pulling the task from this database and putting it for execution. And we now know why this needs to be separate. One pulling the task and one sending it for execution. First is specialized machines. Second is number of database connections. Right? Okay. So select start from jobs where scheduled that is less than now plus 2 minutes. Whatever time you would want to pick. This should be a configurable parameter. And pick that is done. So the tasks that are not picked, order by scheduled that in ascending order, limit 10 for update, skip log. You are picking those stuff in that order, order by scheduled that, and you're continuously sending it to this message queue. SQS, RabbitMQ, Kafka, pick your favorite, right? You would need to measure how much time it takes over here. Let's say hypothetically it takes 4 seconds for you to pick a particular task and then 1 second to write it over here. Now from this queue, the bunch of executors will pick up and executing those tasks. Each executor might have a specialized configuration on which a particular type of task should be scheduled. It is responsibility of your task puller or task picker who's picking the task from the database and putting it. You might have multiple queues over here. One for GPU-based task, one for CPU-based task, one for Java-based task, one for Golang-based task. And depending on the task, the command and the type and whatnot, you can make it as fancy as you like. You put it in those corresponding queue. Each queue is consumed by a particular set of workers, homogeneous set of workers. Any one of that worker is capable of running that particular task, and they run it. Now the workers are bulky machines whose job is and having the entire runtime for you to run that corresponding thing, right? Okay. Now for you to maintain that SLA, you just know how much time each phase is taking, so that you know if you are maintaining that SLA or not, and that's really important. Without measuring, you cannot just say I'm ensuring the SLA. Right? Now the next act would come in is burst would come in. That a particular time, there are a lot of tasks that are executed, like that are scheduled to be executed. Especially in this case, let's say a lot of YouTubers want to schedule their YouTube video for publishing. And then it's like, I'll just schedule it for, like, I want to schedule it, but I would schedule it in just 5 minutes. The video should go live in 5 minutes. So people give you very small breathing space. So given that, and you would always see the burst and all. So for us, it's important to scale up the infrastructure and more importantly, scale down the infrastructure to reduce the cost, right? So what you do is you need a brain to do that, who is doing that scale up and scale down. Here we can use auto scaling groups provided by cloud providers, but typically you should not, because it's very particular about your system. The tasks are heterogeneous, as we spoke about it. SQS, like if your task has very high variance, some tasks execute in few seconds, some tasks execute in few minutes, while some take few hours. It's better that you scale up your system by knowing what kind of tasks are scheduled, how many of them are scheduled, what's the average time they take to complete, and then you scale up your pullers and your executors, and in case you have multiple brokers than that. Fine. So this is what the job of your orchestrator would be. It would need to measure, keep a very close eye on all of these metrics. It would constantly be using this database to figure out, hey, what's happening and what's not. And it would be pushing that thing, and it would be scaling up and scaling down accordingly. Right? Okay. Now let's talk about recurring tasks, and then I'll take questions. Right? Chandan, if you have questions, I'm just lowering the hand. We'll have discussion about recurring, and then I'll take questions. Right? Okay. Let's talk about recurring tasks. Now, if you look carefully, this system that we built up until now very beautifully and very optimally solves the problem of executing the task once at a given point in time. Now, what if I want to support recurring tasks? So the way someone would give us recurring tasks is they would give us a cron schedule. Cron schedule like star, 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 star. So execute this task every 1 minute. What would they give? They would give a particular task. Execute this task every 1 minute. Now, given that we have solved this problem really well for one task execution, how would we extend this solution to build a system that handles recurring tasks? The idea is very simple. If we have solved this problem for one task, doing it for recurring tasks is very simple, because up until now, what we did is we had a task table where user registered the task. We just added abstraction on top of it. For example, you have a job. So whatever we did with the task table, say it was the jobs table, which is actually things that are running. The task, the single execution of a task is a job. So what you have is job ID, which belongs to this task, scheduled at, picked that, started at, fixed that, all of that part. Right? And now what we do is we just have this task table, which has a schedule. Now the thing is that now here one very interesting challenge comes in with schedule is for how many things you want to schedule, like how many entries in the future should you be scheduling the task for execution. The idea is that you cannot just create 1,000 entries for the task or 1 million entries for the task or 10 entries for the task. What's that sweet spot? Instead of thinking of recurring things like that, think of it like that when my recurring task is picked up, I will check if the task is recurring. If the task is recurring, when my picker picks a recurring task, it finds the next 10 occurrence of it and schedules it for those fixed time. So your recurring task, when a picker, again I'm iterating, when a picker is picking a recurring task, it knows it is a recurring task because it would check the database for that if it is recurring task or not. If it is recurring task, it would figure out the next 10 iterations from that time, the next 10 iterations, and it would create entries in the database for the fixed execution. Once it completes the first execution, the picker picks the next set of tasks. It would then figure out the next 10 execution from that time. And whichever entries are not there in the database, it would create those entries. So you take a buffer of 10 tasks at a time. At a given point in time, you take 10, 50, 100, depending on how granular it is, configurable. But the thing is, you pick that task, you pick one task, you see it is recurring, you find next iteration, and these are your fixed time at which you would need to execute. For example, if your cron schedule is star, and you're executing at 10:15, you know that the next task would be executing at 10:16, 10:17, 10:18, 10:19, 10:20. Correct? So those instances of fixed execution that on 19th of March at 10:20 or 10:15, 10:16, 10:17, 10:18 a.m. execute the same thing again. Now when the picker runs again and it picks up the same task and it says, hey, this is a recurring task, it will find out next 10 from that time. Like for example, if my task is running at 10:16, that picker is picking a task at 10:16, it would seek the next 10 iterations. 10:17, 10:18, 10:19, 10:20, 10:21. For example, it would say I already have created entries for each of these tasks except the last one. So it would make one entry in the last one. This way, you have a sliding window-based approach where you are not, now you don't have to think about, hey, how many tasks do I need to schedule in advance? It's more about as and when a recurring task is picked up, we are picking up next 10 iterations and putting it into DB and so on and so forth. This way, your recurring solution is just an add-on on top of your fixed solution. And if you look carefully, this is how Google Calendar recurring meetings would be happening. Because there also your manager schedules are one-on-one bi-weekly forever. You select never when you are booking that time. How does Google Calendar know how many entries is Google Calendar creating? It is creating entries for, let's say, 3 months time. And after every month, or when a particular meeting is happening, after every month, it is making like 3 more entries in that database. Right? This is how you can build anything recurring. So anything recurring is not a problem to determine how many do I need to do it. It's a problem of solving fixed time execution or fixed time scheduling first, and then building an add-on on top of it. It's that simple. So again, as I said, when a problem statement seems overwhelming, it is typically very simple. So don't get overwhelmed by that. Keep things really simple. It's not that difficult, to be honest. Just have a structured approach in solving them. Right? Okay. And this is all what I wanted to cover with respect to distributed task scheduler. Right? So skip log, for update skip log, really important. Thinking of concurrency, really important. Thinking of observability when you're maintaining a strict SLA, very important. Then once you have an observability, how do you scale it? Scaling on vanity metrics, not a good option because you need to know how much time each type of task is taking, and then you keep your schedulers and pickers and whatnot according to that. That is more important because that's how you ensure you meet SLAs. Otherwise, you are just leaving it to the fate that I'll meet SLA. If you just look at queue length and the number of tasks, you should see the types of the tasks that are being scheduled, types of the tasks that are there, like the waiting time and the time spent at each phase, and then you would decide on the schedule, right? So what you can try out on your local machine, at least build this thing local. Writing that one SQL query to read multiple tasks in parallel is an easy thing. Write that, right? Although you may think you know it, but when you write and start implementing, you realize where things might be hiccup. Then implement this one part, cron syntax. When a task is getting picked up, figure out the next 10 iterations and schedule it. And so on and so forth. Like keep on doing it. This way you would know how to read cron syntax, how to process them, which library to use to figure out next 10 executions of it, and then see which one of them are in the database and then add it. Implementation specifics, very interesting implementation specifics that you would uncover when you build this system. Right? Okay. Any questions on this? Yeah, Simran?
Yeah, Arpit. So I wanted to understand why we did not go with the push-based approach here rather than pulling from the DB here.
Who will push?
Like use something kind of a CDC or something like that.
CDC is pull based.
Like we get to know that there is some new entry or something kind of that in the DB.
But what if I create an entry that is 1 year in the future? Do I need to execute it right away? No. Correct?
Okay.
Correct. Not every task needs to be executed right now. Correct. I can make an entry of a task that needs to be executed in, let's say, 2025. What will I do with push based thing? And I don't need to immediately execute them, right?
Yeah, I was thinking like there can be a time where there is no job to be executed and we are polling the DB again and again.
So there is no problem in that, right? You would just reduce the number of pickers in that case. Your auto scaling would kick in and it would reduce the number of pickers that you have. Simple.
Okay. Yeah.
Right? Sure. Hema?
Yeah. What I'm thinking is when workers has to provide the update for status of the work, how we can go and kind of update it. So currently it looks like we whatever we have discussed in design, we can directly go and put it in a database. Should we make that part as also async so that because there are maybe too many workers and we
directly synchronously writing it to the database might not be the best choice. Add a queue and update it. Yeah, that's fine.
Okay. And beyond that, there is one more thing which I'm thinking, I'm not sure how we can do that. So as the task comes, we know that this is the execution time of the task before we write in database. So the task API. Should we look into where the task API once it's known and I know it has to be done in the next minute or so, there should be a separate path for that. So that
if it is priority based thing, where you may like directly want to put, so then in the basically that's a good point. Let's say someone just schedule it. Hey, I need to execute it like in next 1 minute. Please schedule it, right? So in that case, you can directly put it into SQS if you want to. But that's still not of concern, to be honest. Why? Because our queries will not skip them in any case.
I understand.
Right? But in any case, we would not be breaching that SLA. And it's very hard for us to breach that SLA. Given that we are going very aggressive with this. Schedule that is less than now plus 30 seconds. We would be constantly picking that up and scheduling it. So even if it comes very late, it's still not that big of a problem. Because there would not be huge queue because we are ensuring separation of concerns at each level. Go on.
So that because everywhere you try to do this, always there is a priority queue kind of a thing that you need to get something done. So maybe we can create maybe a quicker path where directly write to SQS.
So in that case, you may instead of doing that, have a separate infra, like one for P0 priority, one for P1 priority, one for P2 priority. And in that, when you're picking up a task, you decide the priority of the task where it should go to and make an entry of priority over here.
So everything will be kind of replicated beyond the database.
Yes, correct.
Yeah. After database, everything is replicated.
Replicated per priority.
Okay. Just one more question related to that only, but I'm not sure exactly it fits in this. When so there is a salary from Python which says distributed queue, and it gives you the say that you can add a broker which will be connecting between your workers and clients. Is it not that same that they say the SQS that you can configure, everything else is given? I'm just asking.
You can plug out SQS and put Rabbit MQ over here. That's what Celery also does. So the broker configuration in Celery. Yeah, broker configuration in Celery, you can configure Redis, you can configure Rabbit MQ, you can configure SQS. Now it also starts supporting SQS, right? So it's like they just make it pluggable. Whichever you would want to use, you can use it over here.
So it is the same thing. They say distributed queue, but it's actually a scheduler. Distributed queue plus scheduler. Okay. Celery is doing the same architecture.
Very similar. Yeah.
That's all. Thank you, Arpit.
Yeah.
And I think I missed it saying you are looking for escape lock at that time when you were asking me the next, how you will go it for next transaction. And I was focused on that only.
Yeah.
That's what I've said. You skip that row and go to the next.
Yeah. You know, at most times we might know the answer. It might seem too obvious, but using that right term, really important.
Yes.
Thanks for that. Shreya, go on.
Yeah, this is about recurring tasks. So
Mm-hmm.
I am thinking that instead of adding 10 rows, like whatever number we choose, can we just add one row for the next runtime and then when
Good
the job
question.
gets picked up?
Good question. But what if that job doesn't get picked? What if there is delay in that? So it's always better because, for example, if the task is supposed to run n times, due to any reason, if it did not run, you cannot take that risk. So have a buffer for yourself. Right? Adding just one iteration after that is risky. Add multiple iterations, it just gives you that buffer that in case your picker is down due to some reason, at least because task execution is important. The customer cannot say, hey, because my picker is down, I would not, picker as in, due to any reason, there is any outage because of which you are not able to run that thing. Let me converge on that. Where I was going to add that buffer. Let me come back to let's have a discussion after once I cover everything. I want to have this discussion because this is very interesting problem where if you just think of adding one, you want to add buffer but there needs to be a proper justification for that. Let's brainstorm at the end of it, right?
Yeah.
Just do remind me of that. But I want to cover this. Thanks for that.
Yeah. Thank you.
Anubhav?
Yeah, but my question is around the table which we had created for jobs. So, do we really want to store all the underscore art columns in the same table because it has a lot of write logs? Can we separate out some analytics related columns in other table?
Vitamins versus painkillers. Do that. Do it. But why would you want, it's not that if it becomes too huge, you can anyway shard the database. Right? But in any case, the updates are per task that is scheduled. You are updating 1, 2, 3, 4 times. Per task, 4 times per row. Fine. And in any case, you would not have just one database to handle them all. You would have sharded this particular database. Correct?
I was just thinking from perspective of saving the brittle component,
yeah, you can do that. But if you're doing it in asynchronous when batch writing it into the database, it's fine.
Yeah, with async. Got it. And I also want to discuss the rationale behind the next end recurring task, but I think
we'll talk. I did. Because I want to talk about it. We'll brainstorm together. Because while I was trying to recall that, I was not able to figure out the correct justification for it. But let's brainstorm together into figuring out the correct justification. Why not 1? Why 10? Or 10 or as in any number greater than, right? Let's brainstorm it at the end.
Yeah.
Okay. Yeah. I'll take one more question before we move to the next one. Go on, Chandan.
Hi, Arpit. Can you go back to the diagram? Yeah. So, I was trying to understand why do we need DB and then picker? Why can't the API server itself can put in SQS or RabbitMQ, and the API server takes a call on when to publish in the queue and when not to publish in the queue?
What if API server crashes down? Let's say I schedule a task for 3 years in the future. API server will die off now.
But API server can have a thread which is running and it keeps it takes a call, right?
But where it saves that API server crash. Now where do we have the data? This task was supposed to execute it in 2027.
Correct. So I'm saying that whenever a request comes to API server, it stores in DB for which is 5 years or 10 years, which we have to schedule is one way. And then it has some business logic which takes a call on that. I have some set of jobs. I have 10 set of jobs which have come, which are for now and which are for future. What all for now is taken care by some thread. So first thing what it does, it just puts in DB. Whenever some request comes, it just put in DB, and there is one thread which is always running through poll service, interacting with DB, which says that among this all the job stores in DB, which one to be put in queue.
So you are saying your picker thing can be done by task by your API server.
Yeah. This is what is my proposal.
Okay. Now my counter to that is very simple. Why do you want to merge? Why do you want to keep your API server so complicated? Because now that is already handling user-ended request. This API server would be serving UI for your user, showing them the statistics about the task, average time to completion and whatnot. And now you are giving it more responsibility. Now, how would you scale these servers? Would this API server be scaled on the number of requests, or would it scale be on the basis of the number of tasks that needs to be scheduled or that needs to be executed? You are giving too much responsibility to this set of machines.
Yeah, this is the trade-off we are doing, but at the same time, which DB connection, which we are trying to do query, we are avoiding that query is one of the thinking
the load on the DB is still not changing. You are avoiding, you are not avoiding the query. You are just avoiding connections. Correct?
Connections.
Query,
yeah.
The query would remain the same. The number of queries fired on the DB would remain the same. What you are avoiding is number of connections. But is that even
queries
that big of a problem?
Also be queries can also be reduced if you do batch, right? Because I collect I do one query.
You can do over here batch. You can do over here batch. You are just think about your low level complexity of this service. A task API looks like an API, but it's also putting it into this part. It's better to have segregated systems versus having intertangled responsibility, because when you want to scale to millions of, let's say there are 1 million tasks executed at the same time, how many servers would you need over here? Because your scaling policy of a web server would be on the basis of number of requests. But now here it is doing a lot of other things as well. So now scaling of this servers would become very tricky, because now this code base would having your HTTP APIs also and a bunch of threads also, right? Which are doing this, putting it into this queue and whatnot. I would like to keep things simple, segregated, that this takes care of API interface, other takes care of picking the task and putting it. It gives everyone a clear set of responsibilities and a manageable code base. But you can implement it. It's not that I'm against that implementation. It's just that this low level code will become very complex, harder for anyone to understand, harder for you to scale, because now you have 2 parameters to scale on. In case you don't scale it properly, you would definitely be breaching your SLA into scheduling those tasks, because if it gets delayed due to any reason, you're gone, right? You would be breaching your SLA. So it's always better whenever you're designing this, have clear set of responsibilities for each layer that you have.
Yeah.
Especially
why did I raise this concern? Because somebody raised the Celery part also. And what does in Celery, right? API server just tells that I know which task executor I want to schedule at. It directly puts in there, and
it puts into broker. It puts into broker directly, right? Yeah.
Broker to directly, and that broker knows exactly which executor to be called.
Correct.
Right. Correct. So it directly interacts with, and if there is something which we DB related things we want.
But those are immediately, those tasks are immediately needs to be executed. Right? Okay. There is no scheduling per se.
Makes sense.
Right? There is recurring schedule, which then your salary master polls the database and gets it, or rather polls the broker and gets it. It stores recurring task in Redis broker itself, right? Where it stores all of that information, but it is not worth it. Like it is in most cases, salary is used to immediately delegate a task for execution.
Immediate. Okay. So that's the difference. Like when we do just immediate part, we can go with this route.
But if you want SQS, yes.
SQS. But if we have this recurring constraint, then we should have a proper separation of concept.
Correct. Right?
Thanks.
Okay. Thanks for that great question. Now we'll go into a simple extension to this system around message brokers on top of relational DB. Right? So when you're designing message broker like SQS, I'm talking about. So the requirement for this is it should be FIFO, first in, first out. Consumer reads and deletes the message. Like consumer would tell that, hey, I read this message. It gives it a received handle and it deletes that message. And this needs to be high throughput. If you look closely, this is the first half of distributed task scheduler. Because now what we are building is we are building SQS on top of relational database, which means we are building a broker on top of relational database. So what we have is we have a database to store all the messages. So we are writing SQLs. All the messages are stored in a database in a particular format. Let's say store this database and all the messages in MySQL. What I need is I need a bunch of servers that give them ways to expose APIs to get the message, to delete the message, and to put the message. This is what will be consumed by your SQS consumers that we typically write. Right? So what we are building is we are building this. We will expose HTTP endpoints that does this part. Now, if you look carefully, this is very similar to distributed task schedulers first half, where whenever someone puts the message in my broker, what would happen? We would create just one entry into this table. Right? Now, what we want is when one consumer is reading the message, we would definitely have multiple consumers reading in parallel, which means when one consumer reads the message, I want to make it unavailable for other consumers for update, right? When one consumer is reading the message, it is okay for other consumers to read other messages, skip logged, right? When one consumer has read the message and is processing it, the message should become unavailable for other consumers, pick that, right? Making it unavailable for others. The next part is, so that's why if you look carefully, you'd have ID, message, created at, pick that, right? Once a consumer picks a message, does processing, and then deletes it, it would send it, hey, deleting them. And just a caveat over here, you never expose an API that deletes a message by ID. You need to ensure the consumer who has read the message can only delete the message. So why do you need to do that? So that other consumer does not just bluntly fire queries to delete any messages that are out there. So what typically happens is you have something called as receipt handle. A lot of brokers follow this convention. So whenever a message is read, a random ID is generated, maybe UID, anything random string is generated. It's like kind of OTP. Think of it like an OTP. A receipt handle is generated. It's a random string. And when you want to delete a message, you would never delete a message by ID, but you will delete the message by receipt handle. So whoever has the receipt handle can delete that particular message. So that's the only change in the API that happens in the case of deletion. So when your consumer is done processing the message and wants to delete it, it makes a call to this API that, hey, I want to delete the message from this queue with this receipt handle, so that message gets deleted. Right? And now there are a few things that you need to think about when you're thinking broker. So first, when multiple people are reading from the same queue, because our queue is backed by relational storage, what would have will file queries like this: select star from messages where picked at is null and deleted is null. So message that is not picked by any consumer, not deleted by any consumer, order by created at, because we want FIFO, limit n, because I want to read n messages at a time, maximum set to 10 or 15, whatever. For update, skip log. Even if there are multiple consumers consuming it, there would be no problem. Because of skip log, there will be very high read through. Right? Then once they read the message, they would also update it that, hey, this message is read. I'll set the receipt handle to something. So update messages set pick that equal to now receipt handle equal to some UUID, where ID is equal to this. So this message was read and these things are updated. So pick that is set to this, receipt handle is set to this. Because message pick that is set to something, now what happens? Because message is picked that to something, other consumers, when they fire the same query, they would not get the message, because the message is picked that the message is picked that is set. Right? Okay. Now, what could happen is in SQS, typically there is this feature where if some consumer has consumed the message, but it has not deleted the message, you can configure a visibility timeout. Let's say visibility timeout is of 10 minutes. So if in 10 minutes, the consumer does not delete the message reappears at the front of the queue. How do you implement this? Very simple. You first need a job that says if a message is picked at but not deleted in 10 minutes, I would delete it. Or I would set the picked at as 0 or null. So what you do? If message is read but not deleted, then after 10 minutes, it should resurface. So what you do, you write a simple cron job that would run as a separate machine over here, whose job is to continuously ping this database and fire this query. Update messages, set pick that as null, where pick that is less than now minus 10 minutes. where pick dat is less than now minus 10 minutes. So if your current time is 10 minutes past the pick dat and the message is not deleted, then you do this part where you set the pick dat as null. As soon as you set the pick dat as null, next time when a consumer comes and reads the message, it would fire this query, pick dat is null, delete dat is null, pick the message. So the message resurfaces at the front of the queue. When I first read the documentation of SQS, that message resurfaces the front, I was thinking, oh my God, how amazing is this now? Message was not deleted, but it resurfaced at the front of the queue. How? When I started thinking of implementation using relational database, it became so straightforward that what it must be doing is, it must be doing something very similar to this. Obviously, SQS is not built on top of relational DB, but with this, you know the kind of guarantees you want from the storage layer, the kind of segregation. And I've looked like task scheduler and message broker, very similar to each other. I just wanted to highlight that part, that it's not difficult. You can take inspiration from one system and build another system. Two very different looking systems, distributed task scheduler and message broker. They have very similar underlying properties. Obviously, architecture would be different, but underlying properties are same. One way to figure out some consumer has picked the task, one way to delete it, one way to resurface it, and whatnot. But at everywhere, now, if you are building a message broker on top of relational database, this is how you can build it. But if you're building a message broker on top of any storage layer, you need to ensure you have some way to query the data or some way to access the data in a created at format, some way to ensure that you are taking exclusive lock using mutex as semaphores. Those constructs would change depending on storage layer. I deliberately choose relational database because it makes it easier for us to understand the kind of underlying properties you need from the storage layer. Now, if you're building your own broker, just remove this and write your own storage layer that stores data on the disk. But just ensure that somehow you are updating, skipping log and whatnot. This is where your low-level thread specific synchronization primitives come in. Mutex, semaphores, atomic operations, right? Those parts. Once you have it, you build it. You can build a message broker on top of SQLite, LevelDB, RocksDB, MySQL. In most cases, you don't have to reinvent the wheel. Embedded databases are there to solve that problem for you. Just so long as it gives you properties like this, right? As simple as that. So long as you have properties like this, you can build your own message broker without any hiccup. By the way, there is a very popular library that uses Postgres as a message broker. Celery, because we were having that discussion some time back, Celery also supports relational database as a message broker. It does exactly this behind the scene. You can actually store Celery messages, the messages you put in Celery, and it supports databases like relational database as a message broker. This is how you can build one top of that. And at that, whatever works. It's obviously not very scalable per se, but you still have a decent enough solution. Now you can just change the storage layer, ensure all of these properties are met, and you can build your own message broker on top of it. Right? This was just a gentle introduction to that, to tell you that system design is all about identifying patterns and figuring out a way to solve them rather than getting overwhelmed by God, how difficult the system would be. So this is one of the approaches that I always take whenever I'm seeing a new system. What I do, I try to figure out similarities with any other system that I know. Then once I know, I try to rebuild that system in that, understand the core properties of it. Once I understand the core properties of it, I see if it's the right solution or not, or if I want to change something in that. But because of a known thing that I knew, for example, in this case, relational database and the properties that I knew that I wanted, it was easier for me to build any underlying storage layer that meets that similar requirements. This is exactly what first principle thinking is all about. That whenever you are thrown a system, and I typically cover this to put emphasis on it, that instead of getting overwhelmed and thinking of complex things, try to map it into something that you know. In my case, I typically go with relational databases because in most cases, storage is always the problem. Baki, everything else is okay. So I typically try to map it to relational world, see the kind of properties, and then see if I would want to change relational DB to something else. Right? Identifying patterns, figuring out, like mapping it to the things you already know and building that system around that. Right? Okay. Any questions on this? Okay, but yeah, it's a very good exercise for you to do to build your own message broker and relational DB. A lot of things would get clear when you start implementing it. But schema still remains the same. That's the beauty of it. You just need to identify those patterns and move along with that. Right? Okay, now what we'll do is we'll take a quick break. We'll take a Anubhav break. We'll take a okay, we'll take a quick break for 5 minutes. We'll come back at 10:50 and we'll discuss YouTube views counter. There is one high level pattern that I want to talk about, and then we'll discuss flash sale. Flash sale would be shorter discussion, relatively shorter discussion. It would not be huge, but YouTube views counter will be an interesting one. And then we'll design flash sale and then open forum like always. Right? Okay, chal. See you folks in 5 minutes. But before I go, I'll just quickly drop. I should have copied it. Sorry, my bad. I would drop that. I'm just dropping the links in the Zoom chat. One for testimonial, one for rating. It would mean the world to me if you leave a testimonial. Chalo. Thanks, folks. See you folks in 5 minutes at 10:50. Okay, let's talk about YouTube views counter. Let me quickly check on mic and this thing. Yeah, let's talk about YouTube views counter. So the idea is that we want to count the views happening on YouTube videos. The catch is that we need to filter out some views as per some rule engine. We'll not build rule engine, but we need to still filter out, like assume that there exists a rule engine. Given a view, it tells if it is genuine or not. If it is genuine, I'll keep it, otherwise I'll discard it. Right? Now the job of this rule engine, like why do you need rule engine? For example, if a YouTube creator is watching his or her own videos, just refreshing the page to increase the view count, YouTube typically filters those things out, right? So YouTube needs to have some rule engine that filters out spammy views, right? So assume that that rule engine exists, right? Or for example, let me give some concrete examples on the rule engine. For example, if some person has watched this video twice within 5 minutes, don't count it as 2 views, count it as 1 view. If a video is, let's say, age restricted, but somehow if somehow a kid watches that video, like obviously glitch in the system, you should not count that view, right? Why it is important? You'd say just view. What would happen if I do count plus plus? Views is equal to money. YouTube pays creators by the views that they bring in, because views means advertisements, right? So there is a reason to filter these things out. So now, how do you go about it? So assume that there exists a black box for rule engine whose job is to tell you if it is, you need to filter, you need to, like, is this view genuine or not? Okay? Assume that exists. Assume that YouTube views are coming in some form. We'll discuss that form, and then at the end we will do count plus plus in the database, right? Okay, how do we go about this? Raise your hands, I'll pull you in. So I'll lay the foundation while someone raises the hand that there are multiple people watching the views or watching the videos. It is coming to our service. Go on, Mohit.
So I'm thinking on the lines, if we have some sort of a Kafka broker, which is giving us some live feed over views on videos.
Perfect. And why did you choose Kafka?
So Kafka would give me a very high write throughput for all my views which I'm getting. And
so
then
what would each message contain?
So each message I would have some sort of a video ID
and user ID,
unique identifier of the video, some unique identifier of the user, maybe some additional details like IP address, from where the video was watched.
So anything that your rule engine requires to disambiguate, you'll put it there, correct? Okay.
Yes.
Now you have the messages over here, right? And then you'll do some sort of count plus plus. So let's say there is a quote unquote counts DB where you are storing that this is the video, this is the count. It might be a videos DB itself, it might be a separate database. That's a different problem to solve. But let's say you have a database where you will do at the end count plus plus, right?
Yes.
Okay. Now, where does rule engine comes in? You have now all the views in Kafka.
Okay. I'm not sure what kind of APIs does this rule engine provide, but
given a set of videos, simple, given a set of video IDs and this meta information, let's say 10 of these messages, that JSON thing you pass to rule engine, it says out of this, consider this 2. That's it.
So in that case, like your consumer, Kafka consumer itself would invoke the rule engine API. Like you will get a batch of video IDs in one batch of records in a consumer, and you could basically pass that batch to the rule engine to validate which views are valid or invalid, and based on whatever it returns, like I can update the database based on that data.
Means after this, you would directly write to the database to count plus plus and so on and so forth.
Yes, here I'm assuming that my Kafka
is
partitioned based on video. In that case, that would be sufficient, because in that case I would be doing count plus plus in a single transaction. Batch
updates, right? This is very important point. Partition by video ID. In case it's there, then you can do here count plus equal to n. Because for you to do every time if you do count plus plus micro writes on database, your database would die a very, very brutal death. So that's where it's very important to do batch writes on your database, which means it would be ideal for you to have this Kafka be partitioned by video ID. Really important for you to have that. In case it is not there, then that adapter pattern that we discussed in the social network week, you can put that adapter pattern and have it in that place and then move forward. Okay. But Mohit, this consumer writing to this database directly, do you not see a problem? Yeah, or rather, can we improve the system?
Like, I'm unable to figure out basically the problem here, because like the consumer counts would be limited. So like my number of connections to the database itself would also be contained within a bounded number. And then I'm doing batch operations.
That also seems optimal. So
yes.
Okay.
Maybe I'm missing something.
Yeah, no, that's fine. That's fine, man. That's fine. See, this is where the fun lies, right? Because this is solving, like this system, if we look carefully, this system solves all of these requirements. That too optimally, without any problem. But then we have to read between the lines, right? This is where, like, this is what, again, as I always say, my senior staff probes me so much. It just keeps me think critically about every system, just extensibility at every point in time. And that's what actually makes us better engineers. So I'm just basically putting forward that same thought towards all of you, that read between the lines and see, can something be done over here? The hint is that would be no extensible and no redundant work. This is the hint.
I think one thing I could add here is that maybe if I add another Kafka here, which gives me valid views, like one was a gross view, and out of which if I start publishing this data into, let's say, a valid views Kafka topic, that could serve as a source for other systems as well. Because now we have basically a scrubbed data.
Yes. And this is so important. Why, Mohit? Given that you are on fire today, why?
I mean, we have already done some
separately.
We have already done some processing using this rule engine. So why let other systems do that thing again?
Exactly. This is precisely why wherever you do, and this is why I just want to talk about the system, because batching on all, now it looks like everyone is now thinking of batching at every step, which is brilliant. I want all of you to think on those lines every single time. You folks are thinking about the always about, hey, if I'm partitioning something, what should be the partitioning key? You're always proactively thinking about that. Brilliant. Now, this is what the third point that I want to bring about is around thinking of whenever you're doing something expensive, not trying to repeat that same operation, like let other systems not do that same repetitive operation again, is something really important. It would not help you make this system better, but it would help you definitely make other systems, your entire infrastructure, a little more optimized. Because now, if other system wants to consume views, they would also, like, if they consume from this Kafka, they would also have to like filter out some views and whatnot. But then why to make, like, this would put additional load on rule engine, doing that same repetitive grunt work again. And then wasting so much of computation power. Plus, this is not low throughput. This is very high throughput. Views and rule engine is in itself is very costly because it is typically some machine learning based thing, maybe random forest, maybe decision trees and whatnot. All of those computations, repetitive computations you are doing, redundant work you would be doing. So it's always better. Always remember this. Storage is very cheap. So if you can somehow, if you know that you are doing something a little more expensive, and I might do, or I might reuse this thing in the future, it's always better to re-ingest it in some other storage. Maybe in this case, a Kafka fits because we are filtering it or putting it in another Kafka and then updating the database from this consumers. So you would have a set of consumers over here. Wait. Whose job is to update this database, just so that no one is confused. You have this and you have this. And this way what happens is that whichever system now wants filtered views, a lot of hard work is already done. So other system can easily start consuming from this side. Let's say your analytics system, your search system, payment system, because again, payment is very important thing, right? So if my payment system wants to process these views after filtering it out, it's not that only we are doing count plus plus, but also payment system can just consume from this Kafka and basically compute the payout for the YouTube channel. Right? So grunt work, wherever you are doing, it looks expensive, keep the computed result somewhere so that your overall infrastructure cost is gone down. And this is how you make cross-team impact, that you already have this data handy and not let other teams do that same reprocessing again. Right? Yeah, Mohit, you wanted to add. You went on mute.
No, I think that's all, man.
Yeah, thanks. Hemant?
I think what I was about to say, Mohit has covered. So
super.
Yeah.
Yeah. A lot of senior engineers would resonate with this, but a lot of junior engineers who are you folks, all the junior engineers out there, always think on these lines. Always. That whenever you're doing something little more expensive and you think that, hey, I can store this computation somewhere and it might help some other team, do it. Do it. Let them not do repetitive work. It's better for the organization and better for your quote unquote impact. Okay. And by the way, this is all what I wanted to cover for this one. Right? This is that one high level pattern that I want to talk about. It's okay to re-ingest data into some persistent storage. Here I'm doing it in Kafka. Maybe you're doing some other computation. You might want to store it on S3 or some database, which can then act as an input for some other system. This way, you save the cost for your organization. And FYI, this is exactly what the day zero architecture, almost day zero architecture for any advertisement technology business. So I've had people from InMobi, exact this copy paste architecture that they have. That you would always have something like this. A lot of impressions, ad impressions coming in, basically view events coming into your system. You ingest them on Kafka. You have some filter in place that uses a rule engine to filter those things out. And you re-ingest those things in another Kafka, which then powers your other systems. Always, always. Wherever you see a rule engine in place where you're consuming in something from a message stream, you would always see someone putting it back into another message stream instead of directly updating the use case, because there is very high chance where this expensive computation would be used to do something else as well. Right? So always keep those things in mind. Okay. That's a lot I wanted. That's a short discussion that I wanted to have around this point. Now, let's talk about flash sale. Okay. Here, one thing that we'll talk about low-level implementation of flash sale. For the high-level implementation part, there is a TED talk. So around reliability, fault tolerance, user experience, there is a TED talk, there is a tech talk by Shopify flash sale. If you search for Shopify flash sale on YouTube, you will find a tech talk by their SRE engineer. I forgot the name. There's just one video of that where that person explains around user experience and fault tolerance of flash sale. Watch that video for fault tolerance and SRE experience, as in how they manage it, whatever. It's very simple one. Everyone will be able to understand it. But what we'll talk about is we'll talk about low-level implementation detail, where how are we implementing flash sale? And through this, what I would like to bring about is, again, first principle works. More importantly, you would see how flash sale is how humans work. So it's very much inspired by how humans operate in general, right? So the idea of flash sale is, for folks who don't know, just to set the context, is you have a special sale on your website. Let's say Xiaomi. Xiaomi is doing a flash sale. Xiaomi has Mi 8, which are the latest models. Let's say Mi 8 is the latest model. It takes Mi 8 phones. It has limited inventory of it. Let's say 100,000 phones only. When it announces a flash sale, the flash sale starts at, let's say, 11 a.m. on a particular day. At that 11 a.m., everyone who comes in, who can grab that phone, grabs that phone. There is a fixed inventory. So only 100,000 people would be able to purchase it, right? Once they purchase it, it's done. Once 100,000 entries are done, other users will not be able to get anything, right? So it's limited inventory flash sale. Why it is called as flash sale? Because a lot of people are coming in a flash to purchase it, right? Okay. So this is what flash sale is all about. Now here, what we do for us to brainstorm it, let's start with anything because I want to keep this thing ambiguous, because it's fun to think, to go into random directions when we're discussing flash sale, and I'm there to bring all on the same page, that we don't digress much when we're discussing, right? But the idea is, the hint for this is, break down into different phases. Like, actually today's theme itself is break down into different phases. So break down this problem statement into different phases, solve one problem at a time really well, right? And just one thing, that you think it's a distributed transaction problem, but it is not. That's the spoiler alert, right? Okay, so let's talk about designing flash sale. How would you go about it? Yeah, Shreya?
So, should we start with the database? How the
Let's
schema
start
would
with the
look like?
database. Whatever you feel like. Let the database. Chalo, let's start.
Okay, so a very simple thing would be item ID. We'll have a table with item ID and the count, and then rest details about that item.
Okay. Then?
Hello?
So let's say, yeah, go on. So let's say
Yeah.
your item ID is 1 and some other detail. So in your count is, let's say, 10,000. I'll pick 10,000 as a small number. 10,000 items are there for flash sale. Now?
Yeah. Now
Now
okay,
what
and
happens
then
when someone comes in?
okay, so we are just going to reduce the count when somebody clicks on buy. We are going to focus on that, or maybe what we can do is we can have a total count and then sold count, something like that. No, just to keep track, like how many items we had. Total sold. Right, yeah.
And this is items available. Total inventory,
Yes.
and how many are available. Let's say all 10,000 are available.
Okay.
Okay.
Now, if we go through so this is our database. Now, let's say we have API servers which receive this request of buy this item ID, and then we also receive the user ID. So main problem in flash sales is that we want that atomic operation on that count.
Perfect. So you have transactions to
Because
do that.
yes.
Can
Okay.
you elaborate more on atomic operation? What are you exactly doing in that operation?
Okay. So if we receive two requests at the same time, because we are going to reduce the count, there could be a what do you say, race, something, or like you read the same count and then both will try to reduce it, and it won't be reduced by 2, it will be reduced by 1 only.
Got it.
So we want that. We want to prevent that. Okay.
So
And
you
also,
need
I
that. So
think
you have transactions to take care of that. Okay. But now, how would you know which user has that item?
We don't actually need that has that item, I think, because if we receive multiple requests, I think we should line it up in a Kafka, and then that workers will read one item, reduce the count, get the next item from Kafka, reduce the count. So we should be streamlining like that.
But then that's all about reduce. But now what about purchase? There's also payments flow, right? That you need to accept payments for that, or is this post payment?
No. Okay, so when the request is put in the queue, okay. Okay, so I think this is post payment. So a person would
But then
request
still
it.
problem to starts from pre-payment itself, right? When people come in, you would want on, because there are only 100,000 because there are only 10,000 items are there. Now you first need to prevent accepting payments more than 10,000 people, correct? If this is post payment, then how are you preventing, like how are you stopping from accepting more than 10,000 payments, right?
Okay, I think we should like start from the first, like we receive a request, then okay, we receive a request, we put it in the Kafka queue first, then there's another other set of workers who would
One question, when you participate in a flash sale, you see immediate response that when you click on the buy, it immediately adds to shopping cart. Does this imply that it would be doing asynchronously? No, right? This has to be synchronous operation. You cannot do this asynchronously, correct?
Yeah.
So Kafka would not be there at this stage. That when user clicks on buy. So first, let's take a step back, right? Instead of getting overwhelmed, let's take a step back and see how our interface would look like. So if I draw this interface, it would look something like this. You have some fancy item with a phone or something, and you have a button which says buy. You click on that. What happens when you click on buy?
It takes you to the payment page.
It adds to the shopping cart.
Yeah, cart.
Shopping cart. And from cart, you go to payment, right? So from here, so when you click on buy, it goes to cart, and from cart, you do the payment. Okay. Now my first question is, will you reduce the count when it is added to the cart, or will you reduce the count when the payment is done?
I think when it's added to the not added to the cart, because people can keep it for anyhow, and like they can keep it for days in the cart.
Correct.
So once the payment is done, we should.
But then how are you preventing? But then if you reduce the count after the payment is done, there is a problem. The problem is that how are you preventing, like what's stopping, let's say 50,000 people to add to the cart and go to the payment. And once they go to the payment, amount will be deducted from all of them. But your inventory is 10,000. But you just let 50,000 people to make the payment. Correct?
Yeah, how this works is that it allows you it allows you 10 to 15 minutes to make the payment, and until then it should reduce the count.
Correct, but you are reducing the count after making the payment, correct? So let's say in that 10 minutes when the flash sale started, what's stopping 50,000 people to reach that payment page and make the payment? Nothing, right?
Yeah,
you're
nothing.
not stopping anyone.
Yes. So when the person goes to payment page, what we should do is we should reduce the count we should reduce the item count, and this payment, until the payment request is succeeded, this should be queued somewhere. And if it succeeds, great. If it fails, then increase the count in database again.
Now nothing starts to become complex, right? Okay, but great, we converse with. Now we all know why you should not reduce the count at the end of the payment, because what's stopping other people from making the payment? Like there might be you are now, which means the first step is you should not allow more than N people to even reach the payment page. That's the first step. Right? Then your payment flow can take care of that. We'll talk about it. We'll talk about it. But now it gives a structure to our thinking. We started with something, but then now we know, like when we think about the user experience, we are now starting to converge on how a system should be behaving. Right? We'll talk about it. Okay. Let me pull in Anubhav for a few more inputs before I start converging to it. Go on, Anubhav.
Oh, hey, so yeah, I think the user experience for each item should be somewhat different. So for each item, we should have some sort of a timeout when we add it to the cart. Within that timeout duration is when, like, we'll assume that a user has intention of, continuing with that purchase. That is the time where they should be going to making that payment and then completing it. And within that time. So how make that happen with this table?
But you did it, but you raised a very valid point that if you store it in an aggregated fashion, how would you know for each item the timeout? Correct. So this gives us a hint that aggregation might not be the best way to store this information, because you need per item timeout. Because it's possible that although it's flash sale, but not everyone came at the same time. Flash sale started at 10 a.m., but someone came at 10:01. Timeout for them, everyone's timeout should not be 10:10 or rather 10:20. It should be for people who picked the item at 10 should have timeout of 20 minutes. So let's say 10:20. Or who picked up at 10:01 should be 10:21. So you need to have timeout per item level rather than on an aggregation level. So aggregation might not fit in. So can we alter the scheme? Anubhav.
Yeah, I was thinking like we should have an inventory table where we store that sort of an information where.
What information? Let's say I have items table.
Yeah.
Where you are storing?
Let's say there's a product ID which relates to all the product details table, where we just have an ID for that. We have an ID for this as well. We will need the timeout ends at timestamp as well.
Okay, fine. No. Think little more. So how many entries will be there in this items table?
Product into total inventory, like the whatever is the total inventory for that.
So will there be 10,000 entries for this flash sale over here? So let's say I'm selling MI8 with product ID 17. In the product table, let's say I change this to product table. So I have this ID, which is product ID, which is 17. Name is Xiaomi something. And I have total inventory. I just keep total inventory just for the sake of it. Even if we don't have it, it's okay. I store 10,000 over here. Let me just buy to have it now. Let me just remove it. And now this has a foreign key check over here.
Yeah.
Now you have 10,000 entries. This shows that you have inventory over here. Okay, now what?
I don't think we might want to store it at item level because we don't have that, we don't require that sort of configurability for our system. We can have same timeout for the same product as well. So
no, not timeout, not the total timeout, but when was this item picked up? Because if you add your item to the cart at 10:03, your timeout should end at 10:23. Correct?
Yes.
You need to know that. Correct?
So for if with respect to items table for each of these, we'll have a timestamp called like pick that or something like that. And whatever is the end at, like whatever is the timestamp which it is supposed to end at, like that.
That is configurable, right? That is 10 minutes. So pick that plus 10 minutes is what you don't need to store it in the database, no?
Yeah.
You just need to store when this item was picked by the user. Oh, by the user. You also need to store user ID. That who holds this item at the moment.
Then this table will not remain like the items table. Like if we store that, we'll have to modify this table to.
That's fine. You store user ID. So who owns this item at the moment? Who holds this item at the moment?
At the moment.
Basically, on whose shopping cart is this item?
Yeah.
You need to know that, right?
Yes. And like this can be null as well, and this can be null as well. And when whenever someone adds this to the cart, we want to set this pick that timestamp and this user ID
What would be the query?
Yeah. Just give me 5 seconds to think about the query, because this involves like a lot of concurrent users trying to pick, possibly a lot of users concurrently trying to pick the same item. So we'll definitely need we'll need a lock, and it is going to be a write lock. And also we don't, since we want to ensure high throughput of the system continues, we might also want to skip all the item, like whatever this row is locked.
Correct.
So that is the direction in which I'm thinking.
Done.
For select order by ID for update, skip lock, limit 1.
Correct.
Pick that is null, and yeah, I think this looks good to me.
Very similar to distributed task scheduler. Right? This is the beauty of it. Like when we think of systems, if we think about it in a correct fashion, it becomes very easy to implement. And not even kidding, this is exactly how flash sales are implemented. Not even exaggerating even a bit over here. Let me walk you through on how it happens in real world. We'll draw parallels to that, right? Giving you, like, helping you form that intuition, right? Hemant and Jiten, I'll just pull you folks in a couple of minutes, right? So let me just cover this part in how it used to happen, because flash sale is not a new concept. Black Friday sale is not a new concept. So Black Friday, there is a very interesting story about it. So just go to ChatGPT. Now I cannot say Google about it, but just go to ChatGPT and search why Black Friday sale is called Black Friday sale. You'll find very interesting facts about it. But what used to happen in real world is, in real world, when this massive sales were happened, 90% discount, 80% discount. So what typically a store owner does? A store owner typically fills the store with the stock, right? And it puts the board, hey, I have flash sale, no, sorry, I have sale, 90% off, everyone come, I'll open the gates at 10 a.m. Right? So the first step for you as a shop owner is to fill your entire inventory with items. The exact one that you are selling. Let's say you are having, this is a Xiaomi store. Xiaomi is doing a flash sale in real world. So we'll draw parallels in how it happens in real world and how it happens digitally now, right? So in real world, Xiaomi, the shop owner of that Xiaomi store is stocking it with the actual physical units of the phones, which is equal to we creating this 10,000 entries in this database. And okay, then the shop owner announces we have sale. It's like Xiaomi running the campaign. Hey, we have sale. Now what happens is people gather in front of the store, which is same as, I know if my flash sale is at 10 a.m., people gathering or visiting the website is equal to people gathering near the store, right? So the first step is we prepare the stock for whatever entities we have. Let's say I am selling Xiaomi phone, item ID 720, product ID 720, and these are actual units of that. 10,000 units, I'll have 10,000 rows over here. Now, for each unit, I'll have some meta information which we'll talk about. Don't worry about it. Right? Okay. People lined up in front of the store. People visited the website. I'm drawing parallels. Huh? Now what would happen? The shop owner will open the door. As soon as the shop owner opens the door, what would happen? This sort of people would rush in through the door, the small tiny door, rate limiter. That small tiny door, people are rushing in the store, trying to grab the item. This is where your rate limiter, your door is a rate limiter, where it is not allowing a lot of people to come in at the same time. It's slowly and steadily. You go in, you go in, you go in. The door is a rate limiter, right? Because you don't have the massive door, you have a small enough door, only 1 or 2 people can enter at the same time. Everyone else just streams slide straight. This is what your fault tolerance is all about. It. It's covered in that video, right? Once you have it, now what would happen is when people go in, so in digital world, we turn on our flash sale. What do you mean when we turn on our flash sale? Which means that there might be a configuration in your database that says is flash sale started. It's just set to true. So wherever a page is refreshed, you would start seeing the buy button. Correct? As someone sees the buy button, people click on that buy button. Now, in the physical world, what would happen? The person rushes in. When the person rushes in, the person grabs the first phone that they find. But how? How are they grabbing the first phone that they find? So they are physically going, seeing the first phone which is available, putting their hand on that phone, implying that they now own an exclusive lock on their phone. You would never see, you'd see someone else's hand on that phone, you would not go and snatch it. Some antisocial elements would, but consider that people would not do that, right? So that hand on that phone is equal to an exclusive lock. So what you are doing is users come in, they try to grab the item and they add it to their cart, which means they put their hand on that phone and they keep it to themselves. Maybe a small shopping cart shop owner gives, they put it in that shopping cart, right? Now, this is where your high throughput and contention is all about. So in real world, if you see someone having their hand on a phone, will you go and pick that? No, you will go at some other place because there is an exclusive lock on that. Because this lock is not yet, this phone is not yet put into the shopping cart, but you still see someone else's hand on that phone. This is exactly what our exclusive lock is all about. So what do? You go and pick the item that is not picked by anyone, which means a row which is not logged and an item which is not yet in the shopping cart by anyone or not picked by anyone. You would pick item that, like you would pick that item. So your query goes something like this: select star from units where item ID is equal to 720 and pick that is null. Order by ID, limit 1, for update, skip logged. Right? Now, once you grab an item, what the first thing that you do? That item is yours. You update unit set, pick that as now. That this is the time when I pick this item and I put in my shopping cart. You may invoke the shopping cart API to store it there. Right? But this is precisely what happens in real world and precisely mimicked as is in digital world. There's no difference at all. Right? Now you have said pick that to something. Now once you have picked the phone, it becomes unavailable to any user. So even any other user sees that, you see, a new user comes in, would always pick an item that is not picked by anyone, not having anyone's hand on any phone. You pick that. No exclusive lock. So for update, skip lock and pick that is done. And once you pick that up, you set up pick that up. This is my item. So you said pick that as now by which user? Because that item needs to be by someone. Who picked it? Let's say user ID 1023. I picked this item. It is my item. Because your hand was there, exclusive lock. You picked that item at this time and you picked it up. So it's your item and you have still not made the purchase, but it's your item. Right? So these are the queries that you fire. Now what's the next step? In the physical world, once you have picked that item, what do? You go to the cash counter and make the payment. But if you look carefully, is this a distributed transaction? Not really. Once you have picked the phone, problem solved, right? Because how many people in physical world will be able to pick the phone? Equal to the number of inventory that you have. So flash sale is not a distributed transaction problem. If you're thinking of it as a distributed transaction problem, then that's wrong because it's not. It's just a very high throughput and contention problem. High throughput plus contention equal to locking. So here what we did is, the thing is about flash sale is once an item is picked by a particular user, the flash sale ends there. Item is picked, problem solved. Because you cannot let 50,000 people make payment and then refund money of 40,000 people. You would never do that. So first step, you have to prevent people from coming in when your inventory is done. And it does not mean you are selling your inventory. It implies that your inventory is added in the cart. Finish. Because what happens is, when in real world, when 10,000, there are let's say 10,000 items, when 10,000 people pick those items, what would other people do? The shop owner would put the board at 10,000 rupees because there is very high chance that almost all of these 10,000 people would make the payment. Right? But then the board would be closed, like the door would be closed and said, oh no, we are out of capacity. Our inventory is almost sold. Or rather, please wait for some time. We'll see if someone backs off. We'll let you in. something like that, right? So these users might still be hanging around, waiting for some item to be available, but you can show them sweet enough message. Hey, we already have let in 10,000 people, but in case someone backs out at the last moment, I'll let you in. You can transfer it into real, like some message and show it to your user on the website, right? Okay. Now, when that happened, when a person inside the store picked up that phone, where does this person go? That person goes for payment, right? When that person goes for payment, now what is, and by the way, here, this is where the contention ends. This is your regular payment flow. It has nothing to do with flash sale. Nothing. Because payment flow is in digital world, it's literally invoking other microservice, bank APIs and whatnot. You cannot have this big of a transaction. You have to stop your contention when your inventory is picked. That's it. That's where you stop. Now your regular payment flow kicks in. Now user continues to do normal payment. So in physical world, what would happen? User would go to the cash counter, hand over the card. There are two possibilities. Either the payment is successful. If the payment is successful, the shop owner would say, "Arey sir, congratulations," or "Ma'am, congratulations. Here's your phone. Here's your bag. Get out." So you set purchased by something. Purchased now is this, and your order. You do create order, send notification, alana dhinkana, you do everything, right? On successful payment. And how does that work? With webhooks. So you need to know, like, just go to Razorpay's API document on the kind of APIs that they give, and that's how payments work. The way you get it, by the way, is through webhook. That, hey, payment is successful. So now you can set purchase by something and purchase at something, right? So just to give you a gist on how payment APIs work, you initiate a payment using Razor or any payment gateway. When that bank transaction is complete, they make a webhook call. You have your payment ID linked, and that payment ID pay, you get this webhook call, and you know that this payment initiated by this for this order is now complete. And then you mark purchase at and purchase now to that values, which means that this item is not just picked, but is now purchased by that user, and that user leaves the shop. You close the website. Now the other case is the payment is unsuccessful. Now when your payment is unsuccessful, you went to the cash counter, your payment is unsuccessful, what happens? Shop owner says, "I'll give you 3 more chances, put the correct pin. Otherwise, I'll take the phone." Correct? That's what happens. Because now that shop owner wants to sell that phone, right? So what would happen if your payment failed n times? You make that item re-available for someone else to pick in by setting picked at as null and picked by as null. That this item is now available. So you go and put that on the shelf. As soon as a user sees sitting like outside it, hey, buy button is available, goes and clicks it, goes and grabs the phone. Same thing, right? Again, this is not a distributor. This is a regular payment, right? Here you can have two options to build product experience. First, you make item available for someone else to purchase in case a transaction fails. Otherwise, you say, "I don't want to do it." You undersell. Either you undersell yourself or you oversell yourself and then refund. Up to you, right? But depending on what your product team decides how you'd want to do it. But it's very similar to how you function in real world, right? But once your payment is unsuccessful, the shop owner snatches the phone out of your hand and puts it over here. And by the way, this is also a webhook call. How do you know your payment is successful or failure? These are webhook call that comes your way through your payment gateway. This is how you know it, right? So you would generate a payment ID. That payment ID stitches your bank transactions, payment gateway, and that payment ID generated by your payment gateway. And it tells you that this payment ID is payment successful or unsuccessful. If the payment is successful, you update these 2 entries in the database. If it's unsuccessful, you update these 2 entries in the database. And this is how payment systems work. Okay, now that is done. Now what is an edge case? Some random person just came here for fun, picked the phone up and just roaming around the store here and there and not making the payment and doing nothing. Equivalent to people adding to the cart and not doing anything with it. What would the shop owner do? Shop owner hires bouncers. That if you see someone who has the phone for more than 10 minutes in their hand and they did not make the payment, you snatch that phone and put them back on the shelf. This is exactly what you do with a cron job. You write a simple cron job that continuously keeps on iterating through quote unquote expired items. How do you know expired items? Let's say your expiration time is set to 12 minutes. So what do? You keep on, like you have a cron job continuously running that is updating this database, that is checking and updating this database and it sets pick that as null, picked by as null, where pick that is less than now minus 12 minutes. Then if it has been 12 minutes and this person has not made the payment, put it up. And you don't have to do it for every person. You just keep on iterating this query again and again, because this is what your bouncers are doing. They're constantly keeping an eye on everyone and says, hey, this guy has not made the payment. No, it has been time. So they snatch the item, put it back on the shelf. This is what you're doing if no payment is done after adding to the cart. So now here what you're doing is and this is what completes the flash sale, low level implementation of flash sale. But here, either you are disappointing some of your customers, or you as a company get disappointed by underselling, by basic payment drop, because there is a chance over here that what if someone picked that item but not made the payment? So either you make the item available for other users to purchase, like people sitting outside. So either you do that, or otherwise you say it's okay, I will undersell. So if I said to sell 10,000 items, it's okay for me to sell less than 10,000. 9,000 is fine, right? So either you disappoint some of your customers by accepting the payments and then refunding them, or otherwise you disappoint yourself by underselling that, hey, I'll just resell it in the next flash sale, right? Either way, companies opt for that experience. Pick your favorite, right? But here you see how simple. It's not very difficult to build flash sale. It's difficult to maintain infrastructure during a flash sale. That is a different problem, which is where I want you to search for Shopify flash sale on YouTube and watch that video. And what I talked about, that gate being a rate limiter, sending cute enough messages for people to wait, right? Not giving them poor experience. Person has talked about that, right? Given that it is a cloud native era, whenever a flash sale is there, flash sales are separate systems. Maybe they have their own databases as well. In most cases, they do. So that they are very heavily provisioned to handle that much of load. Here, your infrastructure components for resiliency, like rate limiter, comes in very handy. And you don't want to allow a lot of people to come in. So request should not even come to your backend database. The rate limiter is it sits at the front end proxy that you have. It does not even let someone in. Once there are enough customers, you switch your flash sale off and it shows a very cute message to your user that, hey, we are out of capacity at the moment and something like that. Right? The idea is around garnering a very nice experience when you are out of capacity, or when you wanted to sell 10,000 items and let's say 10,000 people came and picked the items. You want to serve very good experience to your users, right? So you send cute messages on the websites and all. It's all about that. Now, handling scale is really easy. Have a separate system for this. Scale up as much as you can. Understand how much traffic you're anticipating. Understand how many items you sell. That's why you see companies doing a lot of frequent flash sales rather than once in a time huge flash sale. Because once in a time huge flash sale where you are selling 100,000 items would attract millions of people, versus do it periodically. That's why you see OnePlus and Xiaomi did a lot of frequent flash sales almost once every week, right? Rather than doing a big flash sale. Because why to handle so much load? If you can run that campaign, because it continuously keeps your brand name floating around in the market, right? Okay. So now the thing that we just designed, you can take this thing and build Book My Show. Very similar to this. People trying to book movie tickets, fixed inventory, limited seats, people contending for it. One person gets the seat becomes unavailable until the payment happens in 12 minutes. The seat is there. So if the payment does not happen, then seat is marked re-available. Now you know how to build a system. You know different components you needed. You know the low-level details of it. Same thing goes with IRCTC Tatkal booking. Lot of people try to book train tickets on that portal. Fixed inventory, contention, locking. Payment unsuccessful, you mark seats available for other people to purchase. Simple. Then hotel booking, travel to destination, people, fixed set of rooms, fixed inventory, contention, locking. It's always the same. Which is why, if you look carefully, which is why actually today I covered Flush Distributed Task Scheduler, Message Broker, to cover the part of pick that and having to form that intuition around it. Because of it, flash sale becomes really easy to build. And the way we approach flash sale was exactly how people behave in real world. There's no difference in that. So again, as I said, very simple. Just break it down into smaller sub problems. Go take baby steps and code it out. Right? And what I would highly recommend, watch this video for high level, like handling scale. We know scale up database, scale up this, send cute messages. That guy has covered it exact same part, but you get deeper idea on how to craft good user experience when your flash sales are high. Right? And how do I know this? I built very similar systems. We had a massive event at one of my exemplars. We had to build it out. This is what worked. We spoke with a couple of folks. This is how they built. So our intuition was correct. I'm like, okay, okay. This is as easy for us to build. Shipped it in 2 days. We required 1 full day to configure infrastructure, but 2 days to code it out. It's really that simple, right? And always think on like small steps rather than being overwhelmed by it. Think about small steps and it's not that difficult, right? Okay, that's all what I wanted to cover for session. I'll take questions. But before that, before Fox starts to drop off, I'll just drop a note. Tuck. For, oh, sorry. I forgot to remove the percentage 20, percentage 20. Please. Leave me a testimonial and rate this course. It would mean the world too. And now, if possible, drop a note on social media. Now. I've never requested this, but in case you find it really amusing, do drop a note on social media. Like it would just give more credibility. People, for some reason, people think it's fake. They are not fake, they're real testimonials. I cannot write so many testimonials. But yeah, if you feel this is very helpful, do share it on social media. More than happy to acknowledge that and thank you there as well. But yeah, more or less this would go on. But any questions, more importantly? Let's ask questions first. Okay, any questions on question? Yeah, go on, Hemant.
Okay. I mean, in terms of what we have designed, the intuition that you have said it. So as we see, as the request comes in, or a queue comes in the real life, or I said queue. I mean, as the people comes in, we try to build a queue. Should we think the same perspective here also?
Yes. That was my first ever design of Flash sale. And that's such a brilliant thought here, but such a brilliant thought. Because if you look carefully, if you imagine a park, a lot of people are queuing up to go inside that park. There is limited tickets available. So we put them in a queue. So now here, what we did over here, you can actually mimic this with queue.
Yes.
That who gets in? Someone who gets a message out of the queue. So use atomic properties of your queue to allow people in. Rather than doing what we did with this for update skip log thing, you can just put 10,000 messages in a queue. Whoever gets the ticket goes in.
Yeah. That's why I thought of initially that I need 10,000 or whatever entries, maybe with a token ID 1, 2, 3. Like in real life, we do is if you go to a flash sale in the real life, what they do, as soon as you enter in the gate, maybe they will give you a token counter 1, 2, 3.
Correct.
And that's all. The problem is solved there only.
Yeah, you can do that. But in that case, you might just need to restructure a few bits of it. But yeah, you can do that. There is not one way to build a system. You can take inspiration from anything. So I always take that park analogy where people are put in a queue. There is limited set of tickets that are there for a show. They're put in a queue. People who gets a ticket goes in and makes it. But you still need a database to store that, to keep that information intact. But that is just a gateway for you. Who comes in, right? But yeah, you can very well do that.
So in the real life, what we need to worry is about, as soon as the time kicks in on the site, and the people who clicks that buy button, they goes in that one single queue. Yeah. Like here you do in the database. What I was thinking is I can just simply, as soon as buy goes, it goes to Redis, DynamoDB, or other. In actual real life, AWS just on DynamoDB. So this is just add an entry there, and it becomes a queue. And
you can do that. You can actually build a working flash sale using just queues and some streams of DynamoDB and store that. Like, all of that is possible. Yeah.
Okay.
I'm so happy that you and I think very alike in this part. I love it. Because this was my first ever, when I was first thinking of designing Flash sales, this is exactly what I presented. Hey, this looks like a queue. And even basically Shreya also started with that. Right? And that comes very naturally. But given that, if you look carefully, because we designed message broker, we realize that queue is just relational database on that part. So you can actually do that exact same thing over here. Okay. Thanks for that, Hemant. Anything else?
Yeah, I have one a bit different question, not necessarily in this, so I may ask later, but I am just giving a hint. The way we think here is database powering the message queue. I have seen few people proposing message queue as a database.
We'll talk about it today.
Yeah, maybe you can. I have seen the Martin Clipman's one of the video where he describes this thing in detail. Maybe if you can add few things there.
Yeah, we can do that. We can do that. At the end, I'll do that.
Thank you.
Yeah. Rajiv, go on.
I don't have any question for Flash sale, but if anyone has, I'm happy to wait.
Okay. Any question on Flash sales first? Either I covered it really well or no one understood a thing. Either it's one of these two. Irrespective, try to implement, folks. Try to implement. It's not that difficult, trust me. And the way, like, it might be looking very easy because we laid a very strong foundation right from week 2. So it was like grand finale of everything that we did for a very long time now. Right? Okay, Mohit.
So Arpit, just an extension to what we discussed on Flash sale, I think when we look at bigger systems like IRCTC or Book My Show, so when we say that we lay out the inventory upfront in a inventory-based system, so for example, IRCTC, you may be running a lot of trains. Each train will have a lot of seats. So we are looking at a lot of rows in the database, right?
Yes.
Could probably go in millions. Now, like, what would be the different ways by which we could kind of contain this, like maybe seed table growing too huge? Because when you are running that select query, that itself will like start slowing down with time when you have a lot of data in that table.
Do you require old data in the database?
We don't require old data, but I was thinking on it, like maybe if we could partition this table somehow.
In case of trains, you can do that. You can have 3 partitions, each handling a third of the train. Right? But for you to reduce the size of the data, but you are very correct on it, that if you have unnecessary data floating in your database, it would slow things down. Right? It would slow things down, like because your select would start to take time, your updates would start to take time. So what you do, you just need to store data for like last 1 week in case of trains. Other data, you can archive it on S3. This would reduce the size of the data that you want to keep in your database. Right? So in that case, what you would have, the worst part is 7 into the total number of active trains multiplied by total number of seats in them. That's it. And that will not be huge. So you very rightly picked up that you don't need to keep the data floating in your database for a very long time. So you have an archival job that stores them into S3 for your analytics, or maybe your data warehouse and for your analytics purpose and all. But just keep the hot data over there, which is a multi-tiered story. The entire thing, Spark jobs, read data, CDC, whatnot that comes in. Right? Archive the data.
Okay.
Super. Okay. Any other question, anyone? On Flash sale? 1, 2, 3, 4, 5. Okay. Go on, Rajiv.
Arpit, SQS message queue, if you can go that diagram. Basically, select query where we are reading the jobs. Now, is the table indexed on created at?
Yes.
Yeah, that's answered the question. Okay.
I
was having.
It needs to. Yeah, it needs to be, right? So that
you
can
yesterday
part
told,
this
right,
query.
to see the query. So I just bulb lighted when I didn't see that. So
no. Yeah, it needs to be. It needs to be indexed on that. Yeah.
Yeah, that's answered this
It
question.
needs to be indexed. Yeah, it needs to be indexed on created at, a unique index on, not really unique index, but an index on receipt handle as well.
Yeah, it should be unique, right? Yes. Then if you go to the first, I mean, I'm done with this second design, no question. First design, the design part, the diagram which you draw. Now the first thing is the Kafka partitioning let's say you have a hot
Hmm.
topic called GPU. I mean, if you create topics
Hmm.
on the type of queries, type of jobs you receive, and let's say you receive hot topic is GPU, right?
Hmm.
And then there's a case where you get a million requests, which all of a sudden has to be scheduled at the same time. I mean, a random
Hmm.
use case.
Hmm.
Now, one consumer listens on one partition, right?
Hmm. Hmm.
So the bare minimum case, I mean, the naive case would be like to have a million partition. A consumer group is reading on that, but then you don't know how many jobs at same time would come, right? So
Correct.
you have to configure
Hmm.
a partition, not very low,
Hmm.
not very big, right? But there are
Correct.
always cases because we bounded by SLAs now. We have to schedule as fast as possible. Now that
Yes.
means we need to rebalance the partitions depending upon what orchestrator tells us,
Correct.
right? So what is the cost of rebalancing on the performance of Kafka? I mean, how does it impact
It slows down. It slows down. So rebalancing
SLA
is
now?
very expensive. Yeah, very expensive. Very
Now
expensive.
how that would impact the SLA, right?
Yeah, it would. Okay, so let's discuss. Thanks for asking that question. Okay, so the answer to this is very interesting. The answer to this is you use streams plus brokers. Combination of these two. So in case of hot data, and this is not like for every use case, maybe for something hot, something priority, high intensity, you may go with this way. But for example, that one of the topic, and it's not that right now a topic became hot. I'm just giving a proposed solution for this that is very prevalent, very common. And so, and by the way, thanks for asking. Let's dive deeper into this, and it would uncover a lot of mysteries around this part where you want very high throughput in a system and not be limited by Kafka. Okay, so first of all, we go with Kafka streams over here. We store data in Kafka. Kafka is partitioned. The parallelism of Kafka is equal to the number of partitions that it has. Right. But now you cannot have large number of partitions, you cannot have small number of partitions. Let's say you have some n number of partitions over here, but you still received a lot of messages over here. Now the thing is, for you to meet all of them, it becomes really difficult because there is a very high queued up messages in this Kafka. But you are limited, your parallelism. If you are having 3 partitions, you can anyway only have 3 consumers over here. And that's the problem. So now what you do in that case is, you know that SQS does not have a limitation like this. SQS has just high fan out. You can add, and these are on demand. SQS, RabbitMQ typically, like SQS typically is an on demand queue, right? You are paying for whatever you use that queue for and not for the infrastructure that is running on, right? So with this, what happens is you club the parallelization limitation of Kafka with high fan out of SQS. And what you do is you write a small job that reads from, oh, sorry, this is your consumer. So what these consumers can do is these consumers can each write to 3 SQS. And I'm just using 3 as an example. And then they might have their own independent worker. This is typically how notification systems are set. May not be suited for executors, but will be definitely suited for notifications. It's very high fan outy thing where you need to send a lot of data in a very short time. You might see a bulk notification coming in where you are limited by parallelism of Kafka, which is what you do. You extend it with brokers because you can now, what these consumers will now do is these consumers will read from Kafka from that one partition and fan it out in this thing in round robin fashion. And now the consumers of this broker would then start sending notifications by making call to cloud APIs like APN, Google Cloud Notifications, Twilio, and whatnot. This suits more on the extreme notification use case, and this is how massive notifications are scaled. MoEngage does that. Basically, Ghana.com uses MoEngage, and they do something very similar. So wherever you are stuck because of the parallelism limitation of Kafka, try to put a hack by spinning a quick infrastructure that starts consuming from this Kafka and puts it out into this high degree fan out of message queues, which then sends out the messages and whatnot. That is one way to handle it, Raj.
interesting for Arpit is this is the pattern itself. You have a high QPS on the right side, and you're seeing the high fan out, the QPS suddenly increases. I mean, you can handle high QPS in this way, right? You have a lot of things happening in parallel. So it's a pattern basically,
Yeah.
where you have a limited data and you want to have a high QPS on the systems, you can use this pattern
Yes.
basically.
Yeah.
This is like a pattern which could be used. Yeah. Okay. So one more question regarding you said orchestrator looks at the various the columns basically and decides what's to scale up, what not to scale up, and then we have history to tell that. But then in real life, things can go in a different direction, right? So you learn on that, right? You take the hit and then you learn from it. Let's say you know that for a certain request this takes so much time, or even whatever observation you made empirically didn't hold true for
Might
a
not be
current
correct.
event.
Correct.
Yeah,
Yeah.
current event. So you take a hit and then you improvise, right? This is
Correct.
always you do, Chris.
Yeah. You would always. So you might give, like, for example, let's go on a more practical example. Let's say you are running a task that used to run in 5 minutes, but now you added more business logic to that, so now it takes 10 minutes. Your system needs to learn that the time is now 10 minutes is the new normal and not 5 minutes, right? So instead of going for an average, you go for a weighted average, where more recent the task is, higher the weight is. And that's how you can now predict okay, this is the time in which this task should complete.
So analytics creates rules and rules are fed to orchestrator.
Yes.
Okay, that's the flow. Understood. And one more question for the high fan out thing. So some thought triggered in me that if let's say you have a DB in which you have some certain rules, right? And then you want to have a very high QPS to read that DB, and DB cannot handle so much connections, right? So this use case could be used to, let's say you have billions, very rare case where you have millions and billions of servers want to read some data, right? And then you can use a similar architecture to scale out your QPS, right? If you want
1 DB typically would not be able to handle that, so it's better you shard it. And
but
if it is read only, then what?
No. I mean, the amount of data required in DB is less. It doesn't require a very sharding purpose. But if you want to, if you want to make this data available to billion servers, right?
Got it. So this is not sharding because of data, but sharding because of load.
Load, okay.
Right.
But
if it is pure read only, then you can use replicas for that. But if it is not read only and you are also updating, so you are not sharding because of the data that you have huge, because of which you are sharding. You are sharding because you have high load on each of your, like, even the data is small, but your load, the amount of queries you are firing is high enough.
And infra cost, Arpit, I mean, if you have replicas, you need n number of replicas to handle that much load, right? As compared to this infrastructure. So if you compare the cost,
you would be making money, na, Baba. You would be making money because of it, you are spinning up so much stuff.
And the cost price, if this less than selling price, more profit, right? So if any of such architecture gives me whatever gives me low cost, I will go with that.
Yeah, obviously, yes. You would always
that's
go for
asking, is this the low cost or is that the low cost? I don't know.
No, that depends on what your target job is. Like how expensive a target job is. For example, if these are massive jobs that takes hours to run versus just a notification push, just an API call.
Yeah, just pushing data. Just pushing data.
So in that case, in any case, this is a very stretched out diagram. You might not need this high level of configurability in any case, right? So doing this, I feel is cost efficient because this works on demand. If you go for SQS, you don't need constantly running infrastructure for that. So I feel where you are having micro tasks, as you suggested, this would be little cheaper because this is pure on demand. If you don't have any data, you just pay for what messages you send. You don't need constant infrastructure running for that. Plus, this is managed by cloud, so you just take a step back and let them worry about it. Right? At the end, if something goes wrong, you just give them a call and shout at them, and they would say sorry and give you $100,000 in credits, and you are happy, right? So you play by those rules, but in most cases, I feel, I might be wrong because it's very use case dependent, but I feel given this is on demand, it might be a little more cost efficient than the other.
And the trigger behind was that when the task is shallow, but when the task is very demanding, then you won't go with this diagram.
Because
Reason
then you
being,
have constant running infrastructure is much better in that case.
acha, then on demand doesn't make sense. Okay.
Right.
Acha, okay.
Okay.
Thank you.
Sure. Great. Anubhav, go on.
Here, so I had a question on like Kafka partitioning. So like for even for this system, since we don't know the amount of like the volume of work that is there in a particular task to be done, that could be non-uniform. Essentially, how do we decide our partition key so that the distribution is uniform?
No, so in that case, what I first suggested was to have a type column over here that to take as an input, that from this you derive it's a Java thing or a Golang thing or what type of task it is. You can take that as an input from your user. If let's say it's an internal product, you can take that as an input from your user. That is this a low intensity task or a high intensity task or a medium intensity task? And you can then partition it by that if you want, so that you can scale up your executors accordingly.
Yeah, that makes sense. Yes. I had another question on message broker. I missed I think I could not understand the rationale behind the receipt handler. I misunderstood.
Oh, okay, fine. Okay, so what could happen is if let's say you don't have a receipt handle over here, right? You just do this. Now, how would you delete a particular message? Let's say a consumer has consumed a message. Now, consumer wants to delete the message. Now, how would consumer delete a message? Consumer will make an API call which say, hey, I want to delete message with this ID. How will you verify that the consumer who has read the message is the one who is deleting the message? What if some other consumer makes an API call and deletes message ID 5, but that consumer did not even read that message?
Yeah.
You need to somehow know that this is a consumer who read the message, and now it is authorized to delete the message. Correct? You may think of a solution that, hey, let me have each message which consumer read it, right? And then when that consumer fires a request to check if this consumer is the one who read it, then it was allowed to delete it. So instead of that, a stateless approach for that is to add a receipt handle. So what receipt handle would do is whenever a consumer is sent a message, along that message, you also send them a receipt handle. That for you to delete it, just make an API call with this receipt handle. This way, what happens is that you are ensuring that a consumer who has read the message is the one that is deleting the message. Now, for example, if a consumer read a message, but before deleting, the process reboot, but it stored receipt handle somehow. But that message was read by some other consumer now because of the visibility timeout. Now that consumer will get a new receipt handle. This would become UUID 2.
Okay.
This way, consumer 1 cannot delete this message now. Only consumer 2 can delete the message.
Yeah. So
this is what we are solving with receipt handles.
Understood. That is why we need idempotent consumers also from us. Got it.
Correct.
Yeah.
Correct.
Just also looking forward to that discussion on in why do we need the end recurring tasks or why
let's do that. Let's do it. Once we cover all the questions, we'll do that. Sure. Shreya?
Arpit, I have posted a diagram in the chat. I just wanted to confirm that the flash sale would look like that. I mean, it's just a simple diagram, but I mean, there's nothing more, nothing more complex.
Yeah, you would have a rate limiter anyway. Clicks on make payment, goes to rate limiter. If it is allowed, then it goes to API server, does the transaction, and then other components of it. Yes.
That's all. No queuing and all, because
You
in an
don't need
interview,
to
I was
overcomplicate.
actually, yeah, I was actually involved in like, why would you need a queue and all?
I don't think so, because our flash sale work just fine with this. In modern stages, you typically don't. Your machines are more powerful than ever. In most cases, what we built is more than sufficient. Even for a huge companies like Xiaomi, even they don't have complicated. Even Shopify does not have. If you watch the Shopify flash sale video, you'll realize that even their architecture is very simple. Even Dukan flash sales are very simple to design. Same. It's not complicated. You don't need queue. Yeah, you can extend. So there are some additional requirements if they are putting in, which requires a queue, then it requires a queue. But in most cases, this is good enough, because so long as you're able to, justify your design decisions and adhering to the constraints that you are playing with.
Okay. And just because I have not implemented this batch processing in Kafka, I just want to like understand from you how it exactly works. Like, would it pick up batches for the same video ID or just
No,
top
it's
100?
more about the partition that you have, right? Because a consumer is consuming from a partition. So from a partition, you can either read one message or n message. So a consumer is always assigned a partition to read from, correct? So if that partition, so you can say, hey, give me 10 messages. Hey, give me one message. Hey, give me 5 messages. It would give those many messages, right? And then you say commit, hey, I've read till this message, right? So batch is more about you reading things in batch rather than one message at a time. This way, you make fewer network calls to read the same amount of data, because network call is the most expensive part of it.
Okay. Yeah, that's all.
Yeah, thanks. Nitin?
I can't still wrap my mind around the orchestrator logic of auto scaling or scaling down. So, I mean, our task can be heterogeneous, and some tasks can be bulky, some tasks can be very lightweight, and this can vary with the time. Okay, so using all those metrics like the started at and picked up at whatever, like how would the orchestrator on the fly determine like how should I scale and scale down?
See, each type of task would take nearly equal amount of time, won't it?
But all the tasks are heterogeneous, right?
Yeah, but each type of task, let's say sending notification is one task, processing video is another task. All sending notification tasks will take nearly equal amount of time. All processing video would take nearly equal amount of time, correct?
In video, that might vary because
you can take an average now. You can take an average from historical data. But now, instead of taking average of all types of tasks or all the tasks ever, you are having a type column that would give you that ability to group, that you see what type of tasks are there. You see average completion time multiplied by 1.5, and that becomes, hey, on an average or this much of time would be required for you. Right? And then you scale things accordingly. Correct?
And also the type of task might vary. Like someday there are a lot of video tasks, and someday there are a lot of.
But each video task would take nearly the same amount of time. Like the cap that you're setting at basically 1.5 times the average of video processing time. Correct? That can remain constant. But now, because your picker would know, or your orchestrator would fire the query onto this database and would see, oh, there are a lot of video processing tasks now. It would know amount of time it would require to process one video on an average, like 1.5 times the average. It can then know that how many executors it would need to process them. It would add that many. This is where you need to know the unit economic of every type of task. This way you give them necessary infrastructure, because if you don't know the numbers, you would not be able to scale them well, as you are also pointing it out, right? So you need to know for each type of task how much time it takes. You set a cap to it and you provision your infrastructure according to that. Slightly over provision here and there is no problem anyway.
Got it.
Right?
And also, okay. So next question is that can we discuss some single point of failures in our architecture?
Which architecture?
Like this one.
What would fail?
Maybe DB, maybe the single SQS.
What happens when DB fails? What would you do?
I mean, obviously, we need to set up a replica kind of system. I mean, passive replica kind of system.
Then it takes place its place, right? If you're using AWS, RDS gives you out of the box. But if you would want to implement, you have a replica over here which takes place its place and have leader election in between them. Solved.
Correct. And so what type of architecture would be suffice over here? Like the passive replica or the multi-tier where master and
passive replica,
node?
standby node. Simple. You don't. If this is sharded database, for each shard you may have one replica, one standby node. By default, cloud does that for you, right? But for each shard, you may have one replica that is doing that part.
Correct. Okay. And what about the SQS thing?
It's cloud's responsibility. Why are you worrying about it? AWS guarantees that, right? It's their headache. But in case it goes down, you still need to be prepared. You can't, like, I just said you can rely on AWS, but you cannot have a dead letter queue. If you're not aware, search for dead letter queue.
Yeah, I'm aware about that.
Then that gives you a fallback option, right? So consumers are not just reading from this one SQS, from the dead letter queue SQS as well. That's your fallback for this. Okay. What else?
Orchestrator.
Orchestrator multi-master, orchestrator in basic master worker mode with leader election. We discussed 3 weeks back. Same thing.
Okay.
The leader election is the base condition of recursion, that who keeps an eye on orchestrator. You would have one master orchestrator, one worker orchestrator, like a set of worker orchestrator doing this heavy lifting. Master orchestrator keeping an eye on the worker orchestrator. If worker orchestrator goes down, master orchestrator spins that up. If master orchestrator goes down, one of the worker detects it and becomes the new master. Leader election is the base condition for that, right?
Got it. Okay.
Done?
Yeah, that's
yeah. So always see, patterns are everywhere. You just need to identify the correct pattern. And always remember, leader election is the best use case of leader election is for auto recovery. So whenever you think who monitors the monitor, answer is leader election. So have a master and workers doing that path. Master monitors the worker monitors the actual thing that they are doing. Worker goes down, master spins a new one, master goes down, worker of the worker takes its place using leader election. Okay, just a minute. I'll switch my headphones. Yeah, thanks for that. Yeah, Omkar, go on.
Hello. Hey, hi Arpit. So I have the question related to second system where we built message broker on top of the RDBMS, specifically related to the how we implemented the visibility timeout. I was actually having a different, approach. I just wanted to validate if it's correct. When we are selecting the message itself in the where clause, if we also add the condition, if pictat is less than now minus visibility timeout, would this be sufficient?
No, but you still need to resurface the message at the top. How will you do that? Because now if you just put it over here, let's say and, are you putting an and clause over here or an or clause?
Or clause in
right?
or clause with pictat is null.
Yeah, you can do that. Yeah, you can do that. But then someone has to, set pictat to null anyway. Because if pictat is not set to null, then you're checking for deleted at. Then that query becomes a little more complex.
Okay. No. What I was suggesting is that
you can do
instead
that
of just pictat equal to null, we also add the below condition, which is pictat less than now minus 10 minutes.
Yeah, you can do that. I got your idea. Where this and this, where pictat is null and deleted is null, or pictat is less than now minus 10 minutes. Which means and deleted at is null.
Yes.
Right? Then it would also match that. Right? But it's always better. But no, you can do that. I'm not at all denying it. You can very well do that. Which means, but in case there are some other states that you're setting, in this case, we are not setting any state. You can actually put this thing over there. But then, in case you are setting the state about receipt handle and all that, that would work. I don't see a problem yet. No, that would work. With an OR clause, that would work. 100%.
Okay.
Yeah.
Okay. Thank you.
Yeah. Thanks, Omkar. That's a good one. Yeah. OR clause with that would work. Thanks. Okay. Anubhav, go on.
Here, Pip. I just wanted to confirm my understanding about the thing we discussed, which was why we separated pickers and executors. So one thing which I was thinking was that the end user of this task API, it can be an actual user, another service, and there could be that the end user keeps retrying the failed tasks, which have a high probability of timeout or failure, and this could be expensive tasks. So, which is why we created this asynchronous dependency to prevent that our picker plus executor machine from going into like we'll exhaust that thread pool which we have available very quickly otherwise.
Very quickly. True.
Is that
Yeah,
the reason?
that is one of the reasons, yes. But the key reason that I believe still is about that if there are a million tasks that needs to be executed at this moment, you need million machines, assuming one machine can pick, or rather million machines, assuming one machine can pick one task. And plus so many database connections would be fogged up. Right? Because each one of them is just picking one at the same time, like one and executing. Right? So there would be very high need of connections on this database. This database would cry.
Yeah.
That's why.
Yep.
My concern is my major concern is that.
Got it.
Because each consumer or each machine, and I say machine, this could be just a thread also. Right? But the thing is, we should not be having like one thread for each thing, because that thread is not only reading it but also processing it. So given that, you would be having large number of connections to your database that would choke down your database. Right? So that limits the number of connections on the database, is a physical limit on it. So you cannot have more than those many concurrent connections. You have Task API already writing to this. You have someone reading from this. So you need to maintain the number of connections to a steady state. That's
so
I
even
still feel that is a bigger reason.
The database, that problem we cannot alleviate. Like if we shard it based on, let's say, we discuss types of tasks, let's say types of tasks plus consumers.
Yeah, you can do that. Yeah, you can do that. That's what I said. So, but then that adds up complexity, because you might not want to do it. Because keeping it separate keeps this database lean, reduces your infrastructure cost. Because now the job of this database is very simple and straightforward. People write to it, other people read from it, and read and immediately delegate, rather than spend time executing it. So these machines would not be bulky.
Okay, this would be lower cost, I think, in that case.
Yeah. Because this is just small reads, or like small writes and small reads that you are doing over here. Right? You don't need bulky database to store that, because why?
Yeah, understood. Thanks a lot.
Got it. Sure. Siddesh?
Hey, Abid.
Yeah.
A couple of questions on this part. So here, I think we also need to auto scale the schedulers themselves, right? We need to monitor and auto scale.
Scheduler as in pickers?
Yeah, the pickers.
Yeah, they are auto scaled. They are auto scaled. The orchestrator scales up picker based on the tasks that are there in the database next 20 or 30 minutes.
Yeah, I mean, yeah, okay. So I think, yeah, maybe I missed it, because we need to auto scale both of them, right? Workers,
everything,
as well as
correct.
yeah,
correct. Both of them. Yeah, I have this one.
I see. Okay. So another question I had up with was, like, I was thinking, I am convinced almost, but I want to clarify my understanding on the DB connections part. Like, if I am doing a day one architecture, that's how I'm thinking. Okay. If I know, like, I have a system which is, let us suppose, in-house, and I won't go to 100K, more than 100K of concurrent tasks, if that is a given requirement, I'm still thinking that I don't need this picker and SQS logic overall.
Okay. What are the kind of tasks that you are running?
Yeah. Good question. So the kind of tasks is, let us suppose, in few minutes, like if my guarantee is in a minute, the tasks will remain in minutes, is the assumption that I'm making here. And I'll give some more details on how I'm thinking of designing it. So the details are basically, I'm thinking I'll keep some, like, basically we'll have to partition the CPU here, because as you rightly said, if you want to guarantee the SLA, there's no way we can give it to executors, right? So basically, if you have CPU affinity threads given, like, that a core is dedicated and you keep reading, rest of the cores you have available. If you're overwhelmed, I am just trying to understand that system should work, right? If the limitations are a bit lesser, like we are on the different side of the world, we are not actually designing a huge scalable system. We are just designing something that works for us in-house. I just wanted to
that day
understand.
zero architecture is typically what you're describing is actually what Celery does. The Python Celery framework it accepts the message and just delegates it to the worker that needs to be immediately executed. So long as you are not worrying about scheduling that exactly at this time, I don't see a need. You can just directly push it to SQS and start executing it.
Got it. Okay.
Right. But in case you need scheduling, that's where this picker you need it. But in case you still want to merge picker and executor, if your tasks are not having very high variance in execution time, it's fine.
Yeah, that's what I was thinking. Like parameters are basically the amount of tasks and the variance. The moment you can compromise on them, then maybe this thing goes away. But the moment you have too many tasks, as you said, the connections is one problem and the SLA is the second problem.
SLA is second problem. Yeah.
Yes. Okay. That's and another thing was I think we assumed homogeneous tasks here, right?
Now, no, even heterogeneous would work.
Because what I'm feeling to understand is if our tasks actually fail, okay, the time we take to understand that it fails has a lot of
longer. Yeah.
a lot of variance. And given that, and one more thing is generally given the task, like at least the requirement that would come up is you would have to collect at least the execution logs, right? Like what happened. It may be success, may be log. I was just thinking that, and the third thing is, which I think is maybe is required, is that task API would be generally asynchronous, right? You just schedule, then you get a notification on whether your task failed or succeeded after few like seconds, minutes, hours, doesn't matter. Right.
Yes.
So there has to be the second pipeline which goes back, like basically in the same direction that comes back.
Tells the user. Yeah. So those are extensions. So again, those are vitamins to the system where what you are doing is, like, for example, first you spoke about logs. From all the executor, the logs would be flushed onto local disk, picked up by Fluentd, put into Elasticsearch, archived to S3. Entire ELK stack you can put in. Right. Now, for you to notify the user that when your task failed, now there are two types of failures. Either it's a handled failure or it is an abrupt ending to the task. Handled failure, you can directly update in the database that this task failed at this time. But if it is an abrupt failure, then there are two ways to do it. Either you wait for the time for you to declare that this task failed, or otherwise there is somehow your worker knows that this task failed. Maybe a small daemon running that will say this task is not running at the moment. Maybe if your worker is having some sort of in-memory state where it is keeping track of these are the active tasks at the moment, then you can actually query the worker. And we actually bring it up, someone brought it up in the brainstorming as well. That is also a valid approach. But if you look carefully, those are not implementation details which I covered. It's more about those vitamins that you are putting in. But you can have a Fluentd ELK based tech or EFK tech stack over here to put the logs, archive them to S3 and whatnot, notifying your users about completion of task and failure of task, known failures updated in the database, abrupt failures, either your worker proactively has a thread running that tells that, hey, these are now my active tasks. So you can assume other tasks have failed. And otherwise, you just wait for the time and declare the task to fail.
Yeah.
Those are possible extensions. Yeah.
Okay. And okay, that makes sense. Yeah, that's fine. And another thing is I was thinking, like we talked about DB sharding, right? I see, like I see a huge problem with DB sharding here. And this is like, because how do you match schedulers, like the pickers and shards now? Because you have to, like, I am not thinking that now each picker is going and scanning all shards.
Correct. This seems like a problem of data ownership. How do we solve data ownership? Consistent hashing.
Okay. I mean, yeah, no, that's fine, but that's what I was thinking. Now your pickers stale, and most of the times your pickers may be idle too because you're
correct.
But anyways, I was just trying to understand.
But you would shard when you have enough workload. Otherwise, shard karne ka matlab. Right. So in that case, if you would want to have mutually exclusive assignment of shards to pickers, you can go with consistent hashing, you can go with range-based partitioning, you can go with hash-based partitioning and whatnot. Right? All those three things fits into that same scheme.
Yeah. No, I mean, I'll tell you the problem. The problem is your DB partitioning is one way. In the sense, once you're done, most probably you're getting back, is how I'm thinking. But your pickers and your workers are like auto scaled. That's why I think this is a problem, because the rest of the things are fine, as you said. Like the rest of the things we can handle because we already have the logic. Now DB, once you partition, I am not thinking that you would go back. And that's where the problem is, because anyways, but yeah, I got the point. I
No.
just wanted to understand that. And another thing I think which has coming to my mind, which I don't know if like what is the standard solution is. So in this type of system, the standard problem that would eventually come up is resource sharing, like compute or storage,
On
right?
executors, right?
Of executors, yes, on the worker side. So like I was thinking, like if those requirements come up, those have to be carried away with the workers, and those should be machine configurations and a single node machine resource handling, right? They have nothing to do with all of these things. Okay, that sounds good, right?
C groups are your friends. C groups, Docker containers for isolation.
Standard solution, right?
Standard
Yeah. No fancy things that we are doing here, because
nothing.
there is a way of distributed on all of that. But and one more thing is like the task that is coming to us, what that task is like, another assumption is that task is something that can be done in a single node is with what we are
assuming. Yeah.
Assuming.
Now imagine that is a Spark job. Then you are actually sparking out a Spark
User
cluster to do it, right?
Yeah.
That's the difference. So for them, for you, then it becomes an API call where you are just waiting for the Spark job to complete.
Correct.
Yes. But that's a good assumption. Like that's a good point that you made, that we are assuming that one node is good enough to handle the task.
Yes. Yeah. Because even and another thing is like, and one more rare problem, which I think once you go into the production is the partition problem here, because everything seems fine, but at least one guarantee that as a system we would like to give is never your job would be executing concurrently because of our returns.
Yeah.
And for that, I think we have to have a lot of complicated logic, because that is where the system, like once you give that guarantee, that's a very difficult problem to solve, I feel.
True.
Okay.
Which is why a lot of systems don't. They keep
Yeah,
it simple.
that's what. Yeah.
Carlo. Yeah.
Handle it on the user side.
Yeah. Exactly.
Cool.
Okay. Thanks for those questions, Siddesh. Okay. Any other question, anyone? Otherwise, we'll discuss that. 10 recurring tasks. No? Okay. Let me brainstorm with you folks on that. See, this is why I love this batch. Like, I don't mind being wrong. I don't mind accepting, because you folks are so much participating. Because unless we come to that answer again, why do we want to do more than one? Like, maja nahi aayega. Okay. Let's think about it. Anyone has any pointers to that? Like, why should it be more than 10 apart from just adding it as a buffer? Like, maybe that just in case sort of reason. Okay, so let me just draft a problem statement once again, that in case of recurring task, what we said is that whenever a picker picks up a recurring task, we will create n more entries out of it. Now I proposed 10. Shreya, I think it was Shreya who said, why not 1? Why not each time it picks up and just creates one next task to be scheduled? It schedules one next task to be executed at a fixed time, right? And I said 10 because just for the sake of buffer. In case anyone has points, I see Hemant raising his hand. Go on, Hemant.
Yeah. So I also started thinking from the perspective of what Shreya said of one task. Buffer is buffer is just helping that there are redundancy available for those tasks, but I am not able to figure it out if we need that redundancy for a region. Okay, and the region can be, let's say, a failure of database, or we should have a backup from where we have to fire it. That's why we should have it. That's why we need to have it. But beyond that, going in a queue and having some problem in the queue can be another thing, but still I'm not able to figure out a way there. So it looks like it is making sense, but not sure where I have to, what is the proper region?
I think I got it, but I still want to hear your thoughts. But Hemant, because buffer is there, but again, as you said, why is there a need for a buffer? Like, why can we not live without it? Can we not just schedule one task in the future? Like, there has to be a strong reason for that, right? Let's keep brainstorming on that. Siddesh, you want to add?
Yeah, but I think so. One reason is like, let's go to the process, right? What we are doing. So you are scheduling a task only one task in the future. So the next task you will schedule. When will you schedule the next task? When there is a state change on the first task, right?
Correct.
And I think that's the problem, because the state change on that task is not guaranteed to be less than the frequency of the given task.
Got it. Sahi baat. Yeah? Okay. Thanks for adding that. And now this actually clears what my assumption also was. Like, actually, I tried to convey the same thing while I was answering, but even because I was not convinced while I was explaining, that's why I said, let's carry it at the end. But points from Hemant and Siddesh helped me converse to it. So my reasoning for that is that, let's say I have my task scheduled for 19th March, 10 a.m. So let's say this is my fixed schedule, or sorry, this is my recurring schedule that I set. I'm just making a note over here. So which means every time when my task is scheduled, if it's a recurring task, I'm adding one more to that. But when I'm adding one more to that, when my previous task is getting picked up, right? So now when my 10 a.m. task picked up, it made an entry of 10:01. When my 10:01 task picked up, it made an entry of 10:02 and so on and so forth. Right? Now, if I don't add buffer, and now let's say if I picked up this two task is scheduled, now let's say 10:01 task breached the SLA and it executed at 10:03. Now, when my 10:03 task runs, right, which means when this task runs at 10:03, it would pick the next iteration, and the next iteration that it would pick or it would make an entry for would be 19th March 10:04 a.m. So because of, and then when this task picks up, it would make an entry for 19th March. I hope today is 19th. 10:05 a.m. and so on and so forth. So you literally, because you breached the SLA on one of the tasks, you have missed executing it 2 times, 10:02, 10:03. So it might not be okay. And you might think, hey, but my task, maybe like basically whatever the task is doing, it might be idempotent. That, hey, it might not be missing processing of anything, but that you don't know what kind of task that customer has scheduled. They might want that fixed sort of execution. For example, let's say whenever the task that is scheduled to be executed at this time, let's say the task creates exactly one entry in the database. Now, because you skipped 2 tasks over here, there would be 2 less entries in the database. The customer said, hey, but I told you, this task needs to be run every minute. So it was expecting n entries in the database, but now there are n-2 entries in the database. Not the task, like the actual job that they are doing, that thing. And because you don't know what customer might be scheduling or customer might be executing, I'm just going by the thing that if a task is scheduled to be run n times at that frequency, it should run n times no matter what. If we breach SLA, we breach SLA, but guaranteeing n execution is important. This is my rationale behind it. Shreya, you want to add?
Yes, Arpit. So we are taking the maybe pickup time into consideration, but can we add a new row when the job is getting picked up by the executor? I mean, not before pushing it in the Kafka itself for processing. So let's say at 10 a.m. the executor picks this up, and it's one more job is to, if it's recurring, add a new row in DB and then put it in Kafka. Then we won't miss such times also, right?
No, but if I cannot pick up due to any reason, I don't pick up because let's say my picker stopped working. But then anyway, I won't be correct. But let's say because my picker stopped working, then I would not have entries for those fixed schedules. Correct?
But then, I mean, nothing would be picked up then. I mean,
no, but then you still need to guarantee it, right? That even if it is okay for you to do it with breached SLA, you should still do it. Like I'm just thinking about it because I'm just thinking from the kind of guarantees we are promising to the customer. Because if I'm guaranteeing that no matter if my system is down, I still guarantee n times execution for your n time schedule. Then I have to ensure that. If I'm not giving that guarantee, I can skip that. That's what I could think. Right.
Okay.
So I believe this is more coupled with the guarantees we are promising to the customer. That if your cron is scheduled to be executed n times, no matter what, it will execute for n times. And I believe this is the kind of guarantees distributed task scheduler with recurring schedule should come with, or rather should offer. Yeah, because you cannot just say because it was down, I did not execute. But but again, as a counter proposal, it could be that, hey, me as a distributed task scheduler, I give that thing. If my task is down, those things are skipped for the recurring schedule. If that is okay, you can still do one at a time. But again, it's good enough to have a buffer per se. But that's not a good reason. That's not a good reason at all. If I'm guaranteeing this n times execution of the task, I would want to have that buffer in place.
Okay. So thinking about implementing this buffer, how do we know that like only one, like let's say the first one added 10 units in the database, and then next one needs to know like I just need to add 2 more now. How do
No,
we
it would
implement
generate the 10. It would try to insert 10. 8 would not get inserted. 2 will get inserted.
Okay, so the unique key would be the timestamp here. Primary
So
key
you would
would be
know
the
now.
time.
So you can either read and say, okay, these 2 I would want to put in, or you may just have a unique key on that. Either way, if the entry exists, or you may just run a simple upsert. Even that works, right? Even a simple upsert, you may not have to get and check. You may just fire a simple upsert command in the database.
Yeah.
Right? Hopefully that,
Okay,
even I am not convinced. Even that probed me little harder, but it's good because it's just that more about, I'm just thinking about a kind of guarantee. Like I could, at this moment, I'm only being able to think about the guarantees that my task scheduler would be providing, depending on which we can pick this up. Okay.
yeah, I mean, if the picker fails, we still have rows and DB.
Exactly. So we are just trying to minimize the number of tasks that user would see as not ran, right? Because we already have those entries that executors like, but still picker is not the kya pick karega, right?
Okay.
But at least in case, even I'm admitting that I'm not convinced on that part. But it's again a good practice per se, but I don't want to put it behind the blanket of a good practice. There has to be a very solid reason for that. But one more reason that I could think of out of this context a little bit, that in case of Google Calendar, if you are setting recurring meetings, and if you use the similar logic, you might want to see like 3 months event scheduled in front of you. Right? It's a totally different use case, but that is one around user experience. That there you need to schedule few more in advance other than one at a time. Right?
Yeah.
It might not fit in this case, but in that case it does fit. Where pehle se set karke rakh lo, because you never know what might happen if your Google Calendar is down. Like people access, they don't see anything scheduled and they would freak out. What happened to our one-on-ones? My manager is not taking one-on-one. He's chilling out. Right? You don't want that to happen. So you just want to have it safe there.
So Arpit, in that case, you mean that in Google Calendar, if I schedule a one-on-one every day for the next 2 years, it creates those many roles in the DB?
No, not for 2 years. It would create for, let's say, 3 months. And as they move forward, it keeps on adding newer entries.
And then in the UI, if I just go ahead to next year, I still would see
you might not
those
see
roles.
those entries. Yeah, you might not see those entries. Because it is yet to be created.
Okay.
But
Okay,
let's say
thank
if it
you.
is, let's say you want to schedule an event one for every year. And if let's say there are only like, let's say Google Calendar, I'm guessing, I don't know. But if let's say Google Calendar is scheduling, let's say just configuration that it schedules 20 events no matter what. Right? So if you're doing for one-on-one for every day, if you're doing it, or rather, let's take a practical level, let's say you're configuring your daily stand-up for every day, given that it is very frequent, it might choose to create 100 entries for that. But if it is very infrequent, it might want to do it for, let's say, let's say 20 entries in the future. So typically, I believe that calendar apps would be working in terms of period. Let's say at max, I would be scheduling things for next 3 months, not more than that. So it would going till that stage. But if let's say you are having an event which is per year, it would still create 20 events for that, something around it, so that you still see that per year the entries there in the Google Calendar. So a combination of these two, it would be applied. That's what I feel.
Yeah.
Right? Okay. Anubhav? Yeah. Thanks, Shreya.
Perfect. So yeah, my point was mostly around guarantees plus user experience only. Like there could be 3 kinds of user experiences that we can offer based on what I can understand, and what I'm understanding is whether it should be 10 or whether it should be 1 depends on that. So basically, if we have a system, for example, where we don't want any more tasks to run after one task has failed, we don't want to even schedule any more tasks. Let's say we could have some systems which, like, maybe our total count or something will go wrong if that happens. So if that is the guarantee, if that is the expectation of the consumer, then we need to configure this end to be one
only. Yeah, that's a brilliant point. Yeah, because you never know what sorts of advanced configuration you might offer. But this is a very good point. That if one failed, stop the execution. I don't want you to move forward. That's a brilliant point. Yeah, exactly. And Shreya, this is a very practical use case for your thing. That why at one place you just want to schedule exactly 1 at a time and not 10, because you don't want to run. Once it failed, it stops. Thanks, Anubhav. That's a brilliant point.
And for Google Calendar or for calendars, what I can see, like I just tried it out while we were discussing, like I went ahead till 2027, 2028. I can still see meetings.
Per day event?
Yeah. The recurring event is still there.
Per day?
Per day. Okay, not per day. Okay, these are weekly events. So maybe that also has
some sort, because I don't creating these many entries in database.
Oh yeah, even per day events are there. Like there are meetings which are 4 times a week, and they are also there in 2028.
Why?
I am thinking maybe there's some optimization on top of it. Like maybe
so they might be regenerating it on the fly, maybe storing it on the front end side and showing it, but it would not do that. But there might be some optimization on that. This is an interesting problem. Google Calendar. Yeah, this is an interesting problem. But let's dive deeper. I'll make a note. I'll dive deeper into this. This is a very interesting problem. That for how long will you create entries in Google Calendar?
Yeah. So I was thinking that if we keep it configurable, then maybe like someone wants to set it 1, for them it's 1. For someone use case like Google Calendar, it could be 1,000, let's say, or 2,000, whatever it is. That was what I was meaning.
It's 2,000 entries for each. It's huge. Like, why? My questions are, why would you want to store it? But again, they might be prioritizing user experience over that storage requirements.
Yeah, good. Thank you.
Okay, anything else, Anubhav?
No, but that was all.
Thanks. Okay. Ratish?
Yeah, I just wanted to confirm one thing here. Can you please move previous slide where we have defined the raw one?
This one?
The table, yeah. For the
table
scheduler.
Of scheduler table.
Yeah. So we have concluded that we will have let's say 10 tasks and jobs in buffer here, and picker will pick that accordingly. So what was I was thinking that let's say we have created 1 row for 1 job over there, and we'll have a frequency column as well. Let's say it's to be a temporal expression for a minute, for an hour, and for a day, for a week, and for a year. And once the runtime of that particular job gets passed out, then we will call our job, and that time system will create another record for that particular job to execute for the next iteration.
So you are having self join in that table rather than having a separate table for schedule, correct?
Yeah.
Now my question is, like, my counter to that is, you might want to show this information in the UI.
Yeah.
How will you show this? Not the jobs, but these are the schedules that you have. You need a place for which you can query this efficiently, right? That these are the jobs that you are running with a schedule.
Yeah, for that, I think we need to keep that information.
Yeah. So that's my counter to that. Obviously, like, because there has to be some user to the system, right? Who sees all these tasks which are scheduled, and they might be able to change the schedule frequency and whatnot. You would have to consider that as well in order to render that UI.
Okay.
Right? But otherwise, if you don't consider that, then you can do self-join and all. That's perfectly fine.
Yeah.
Okay. Yeah. Thanks, Siddesh.
Thanks.
Hey Arpit, I was just thinking more on Google Calendar. I can just give my 2 cents. I don't think you would create separate individual entries for each event. You would generally keep something like start and frequency. And like I have built a similar system in the past. So and
please
some
batao
overrides.
fir to. हाँ, batao.
Yeah, and some overrides. See, take an example of if you want to have a rate limiter, but you want to schedule it. Like you want to limit the rate of the system only for 4 hours a day, because those are your blackout windows or some windows where you want to do rest of the stuff in the thing. Now, what do you do is, like what I'm trying to say is, what is UI showing us? UI is showing us, like it is fetching the data from the database entry, like what is the start, end, and your frequency. And as you render the UI, based on that, it will show you entries till whatever the entry is there in the database. So for example, your daily meetings, you will have from start of March 1st, 2022 to March 1st, 2025, daily 3 p.m. to 4 p.m. is an entry. So it doesn't matter for UI. UI can just show it. The problem is that I checked what happens if you just cancel one of them. I went ahead and canceled one in 2022, just one. Now that problem is basically, I think what they are doing is they just cancel everything post that for now. And when you reach 2022, right, they regenerate that 2023 or 2024, wherever canceled that, they will regenerate an entry and not keep splitting. That's
So
a
it's
simple
more
thing.
like it's more like copy on write.
Yes. It's basically like keep the range queries, because
queries.
Because you know the user pattern, right? Is someone scheduling one meeting, like it is manual meeting schedule. So you can
because what I was trying to do was I was trying to see if every event has a different ID. If every event has a different ID, it implies that there would be those many entries in the database.
That makes sense, but I like, at least as far as if you can see till 2025 and 2027, right? I don't think so that they might.
Exactly. But using range queries also you could very well optimize,
because it is UI, right? Who is rendering
it's
it?
UI.
It is UI.
It's UI.
In database, why does database? But in the flash cell, it makes sense because you are going to keep information. That is how I was thinking. Where you are not keeping any
100%.
information, it's fine.
It's fine. Yeah. So, and if you are, let's say, on each invite, you can change something. So when you update a particular event, you override it. So you do a copy and write in that time and update and create a new entry and update it there.
And that time you updated it. That's fine.
Yeah. So range queries with copy on write might be a better way
with the override thing. Generally.
With an override thing. Yeah. Thanks for that. But range queries, I thought about it, but I found like, because then on front end you might have to send all the events for unknown, but you can actually fire a query on the DB that this is the time schedule, what all matches. Oh yeah.
Yes. Because when you render, you generally render for a week. Like that's the thing that you give, right?
Correct.
Like for months. Like I don't think more than a month you can even render. So more than a month is fine. You just have to take those intersections and render, which is fine.
Yeah. Naive approach for Google Calendar. Okay. Not a good approach, but my approach. Better approach is range queries with copy on write. Yes. Thanks, Siddesh, for that.
Thanks.
Okay.
Cool.
Yeah. Thanks. Amrita, go on.
Arpit, I also wanted to add to the Google Calendar thing only. Like we can separate them out because we considering the case where we had to book the physical rooms, and in case we maintain different entries for weekly and daily meetings,
we might create a conflict for the meeting room in that case.
True. Range queries plus copy on write again. This seems like a very good approach for building Google Calendars. Thanks, Amrita, for that. Learned quite a bit things today. Super. Thanks, folks. Anubhav?
Hey, Arpita, I was just going through the calendar API and it turns out GCal API and they are using like start daytime and daytime. So they are using range query based. They are providing those features.
Great.
I was thinking even if maybe this is just for the calendar UI, but then if it's there in the API, then it's also for the enterprise consumers. They are also relying on the same range query based usages.
Superb. So it's done. Range queries plus copy and write / override is the way to go to build Google Calendar. See, that's why I love brainstorming with you folks. Like, suddenly all of a sudden we started discussing about Google Calendars and now we also designed it. Chalo, superb. Okay. How many survived? It's almost 11 folks, including me, 10 folks. Thanks so much. Any other question, anyone? Great. I know it's long, 4 hours almost. But thanks so much. Thanks so much for this. It was quite an interesting discussion. Thanks once again, everyone, especially Shreya asking that question and then nudging all of us in that. But thanks for that. Great discussion. I'll upload a recording by evening. It will take time for me to encode 4-hour long video. Takes time for me to encode, but I'll upload it by evening. And next week, last week, it's really sad, but God, it went past so quickly. It's all about algorithms. I'll share the pre-reads for that today itself. Right? Ciao. Thanks folks for tuning in. See you next week. Bye-bye.
Thanks, Arvind. Thanks, everyone. Bye.
Thank you, Arvind.